Evening, everybody. This is Pete Morse for the Comanche Zoom for the 17th, 16th, whatever it is, this Thursday night. Here is what we're doing. June 17th, it is. A tutorial on fuel injection and carburetor systems, what they are, how they work, and what can happen to your aircraft if things go wrong, and how you might be able to take care of it. It's going to be a very interesting evening. And as usual, at this point, we'll start with the who you are, where you are, and what you fly. And everybody, you may have to unmute to be able to talk. And if you would mind, remute when you're done so we don't get the background noise. While I'm at it, I'm Pete Morris. I'm in Connecticut. Had a very interesting day. Had to rescue a glider that didn't make it back to the airport. But all in all, I'm still here. I fly a 250 Comanche 1963, which right now is out of annual, but that's the way it goes.
Rich Bergman, 1967 260B, Gillespie Field, El Cajon, California. And this is one of my favorite subjects since I was in almost professional drag racing and held NHRA record, and got to learn a lot about fuel induction systems, and especially on my own plane.
Go ahead and chime in who you are, where you are, and what you're flying. Particularly if you haven't been with us before.
I'm Ray Fay from Madison, Wisconsin. I fly a 260B model, and that's about it. Haven't flown much in the last months because of the dreaded disease that hit the world. I guess that's the best excuse for not flying.
Hello, I'm Lonnie. Fly a 1960 Comanche 180, which also is down for annual. And it seems that there's a world shortage of bungee cords. Finally found some at Webco, but everybody else was sold out.
Whoa, Lonnie, that's good to know because I'm about to go into annual. Hi, everybody. CJ Stump's ready to make you dizzy by walking around and talking. I'll sit down and stop doing this to you. I'm in Vermont at the moment, getting ready to go down and get the 180 from Florida. We've got the Avidyne 540 being swapped out under an RMA and a few other odds and ends to fix. I just heard back from Avionics that I have a complete and utter mode 3A failure. So now I've got to troubleshoot that, but it's an airplane. So who's surprised that I have one or two things to deal with? Anyways, welcome everybody. And the next person jump in, say who you are, where you are, and what you fly.
Hi everyone, I'm Adam Height. I actually have some exciting news. The showroom and everything's open in Arkansas, and we hopefully plan to do the opening event celebration fly-in as soon as I can get back out into the US. I have a 400 November 8502 Papa, and I'm hoping to have the right normal Comanche on the in the hangar soon as well.
Congratulations on the showroom opening, Adam, and welcome.
Thank you.
I fly a Comanche 260B 1968 model. I took it to Sun and Fun in April and had a lot of fun in the process, and met up with CJ at Sun and Fun as well. We had 50 Comanches at Sun and Fun this year, which I think is a pretty sizable number for being at one place at one time.
Yahoo. Hi, Dad. Thanks for being with us, and thanks for being our backup recorder tonight. I believe I just saw a perfect Alan Jesmer in there.
Hi.
Welcome. And
I don't have an airplane, but I did sleep at a Holiday Inn Express last night, and I'm going to talk about the float carburetors and the fuel injection.
We are pretty excited to hear your presentation. I did some thinking about the fact that that first slide about the fact that all of the early airplanes were gliders until we had carburetors. And the more I thought about it, the cooler it was.
Yeah, that's good.
Looking forward. Thanks for being with us tonight, and thanks for, yeah, welcome. So who you are, where you are. Well, so you're not flying anything right now, but you're keeping all of us flying, and you are where?
I'm in Arlington, Washington,
State.
on the left coast.
There you are.
Yep.
Where it is earlier and a little bit later than here.
Believe me, I'm still as tired as you are, though. Been a busy day.
Yeah, exactly. Well, I spent the day, I will let y'all know, I spent the day working on ComancheTown parking at Oshkosh. And we have been looking for an airport to assemble at so that we can fly a big pile of Comanches into Oshkosh this year. And a little bit of a hint to you all that we are probably going to need to assemble early, because at the airports that we've been checking in with, they're like, yeah, we have 60 tail draggers coming in spending Friday night here, and stuff like that. So it looks like it's going to be a really, really big fun gathering there, but vintage parking will be at a premium. So we're going to be super organized. So, well, everybody jump in, say who you are, where you are, and what you fly.
CJ, have you considered meeting on the other side of the lake?
We may have to. What
It's
seems
like
to
a
be
40-minute flight across the lake.
yes, we don't want to make a bunch of Comanche drivers fly across Lake Michigan, but yeah, we may have to. We also have a bunch of, we have so many people from the Wisconsin area. I mean, Ray Fay knows all of the cool spots. So I think people will find a smaller airport, and then we may end up renting a fuel truck. The big problem is getting a lot of airplanes fueled in a short time if there's only a 100 low lead pump, and we're having to, move airplanes in and out, but we'll manage.
Yeah.
We're a fun crowd.
Stopped at Fond du Lac a couple of Oshkosh years ago. Fond du Lac was a great place to stop. And
Absolutely. Yeah. The big problem is, again, because so many people are staging at nearby airports, to find a nearby airport we can stage out of where we are not competing for fuel truck space or overnight ramp space with 50 or 60 other airplanes of a different type. But John Kritschke and Eric Jones are on the job, and I expect they'll solve the problem.
Can I ask, if we are going to do a group flying together, are we going to put the 180s at the front, get them to take off 10-15 minutes before the 250s then, and the 400s following because of the speed differences?
Adam, you are terrible. So everything going into Oshkosh ends up in one of two altitudes, and there is a slightly higher altitude for the fast airplanes and a slightly lower altitude for the slow airplanes, and everybody flies at that airspeed. So we normally put the Comanches at the higher altitude because there's generally less competition. And
I think even the 180s should be up at that higher altitude.
Oh yeah, even the 180s fly at the higher altitude, because even the 180s are fast compared to most GA
compared to
aircraft.
a Tomahawk.
Compared to a Tomahawk, yeah, they are definitely at the lower altitude, and the Air Coups and the Cessna 152s and 172s. So, yep, you throttle back, I throttle up, and
mine's not coming. My 400's nowhere near ready for Oshkosh. We'll be coming in a 250, I hope.
Yep. So, but yeah, so that should be great. But yeah, so the registration link, Pete Morse has updated the registration link. And if you go to northeastcomanche.org and then click on the any form links link, which is right under the big blue bar near the top of the page on the right-hand end of the links listings, you'll see in the bottom right-hand corner of that page, you'll see the link to just put in your information to register for ComancheTown at AirVenture this year. And it should be amazing. Because we're going to need to be in mass on the ground on Friday, with Saturday as our rain date is what it's looking like. We're planning to have Eric Jones has a bus company, and I think he's going to supply a bus. We're going to have a Saturday night dinner. We're going to probably either go down and visit like the Harley Museum, or like if people are casino lovers, they can do a bus to the casino. And we'll also just do some educational stuff. I think we'll probably do a walk around on the ground, and Comanches that are on the ground, and with people there like George Richmond, Zach Grant, etc. I've noticed that what tends to happen is Zach starts inspecting airplanes and everybody ends up with a squawk list. And we'll also take a walk around and look at landing gear because there's a whole bunch of stuff you can see in landing gear just from a visual inspection. So I think it'll be pretty educational. So anyway, sorry, we're anybody who's come in, just jump on and say who you are, where you are, and what you fly. And if you have dialed in, you can unmute by pressing *6, and then you can remute by pressing *6. Go ahead.
Hey, CJ.
Hey,
It's John and Bruce.
great to see you guys. And well, we know what you're flying. It's behind you.
We're on the road. We're on the road. Stuff to haul back Bruce's truck.
That is super cool. So you guys are driving, but your backdrop is John's 400. Nice.
Right. Yeah, it's a virtual background. Oh yeah. So I fly a 400. For anybody who doesn't know.
Well, welcome and thank you guys for the work you're doing on identifying a good staging airfield for Oshkosh.
No problem.
Yeah, we're looking forward to it. And everybody else jump into any quiet spot, say who you are, where you are, and what you fly.
Hey, CJ, how are you doing? This is Jimmy Outreach. Can you hear me?
Yes, we can.
Let me turn this deal. I've got a friend I'm going to try to invite next week when y'all talking about air conditions. He's Greg Turton. He's the one that owns Arctic Air.
Jimmy, that would be wonderful. We will definitely give him a spot for
All
sure.
right. He, according to him, you got to have need a 100 amp alternator on your airplane to run it.
Some of the ones that are coming out, here's the question for that. Most of the Comanches that converted from generator to alternator, if I recall, did a 70 amp system.
I think that's right. That's what I've got to check. He's out of town this weekend. I mean, this week. He told me he'd be back Friday, and I'm gonna get with him. And I'm going to talk to a friend of mine. My A&P has been working with me on mine, and see what we can do. But now that's the same one that y'all show on this Comanche. This 250. That's on the site. That's who made that one.
Okay.
So
yeah.
But that way he can answer a lot of questions.
Sure. No, that would be wonderful because that Arctic air system's been out there for a while and it's tried and true. And then for air conditioning, there are two owner created systems in the works that are designed to be portable and installable either as a owner installed or with a 337. And so those will be less powerful than the Arctic air system, less expensive, and it'll be really interesting to hear what these owners have been doing.
Okay, well, the Arctic air, you don't have to have a STC put them in because they're portable.
Right.
But you can take them in and out. Yeah.
Nice.
I've got one of his ice air conditioners, but and I've talked to him, and I'm fixing to get one of the other air conditioners. But the controls, they're back on back order right now for them, CJ.
The control units are?
What the parts you put on the dash to turn them on and off. That because control. Good thing about a Comanche, your battery's back there on most of them.
Yeah.
And so it's real simple to hook up.
Absolutely. Yeah. I mean, I think it's going to be great. Another thing that's going to be coming up soon is for those who are interested in the installation of the Garmin GFC 500. We've had an owner assisted installation happening, and that one is going to be accompanied with a lot of photos and videos. So,
well, now I talked to David last Thursday. My plane was supposed to be ready tomorrow, and he's had some personal problems at home, something to do with family problems. And so he's not there this week, but when I talked to him last Thursday, a week ago, he called Garmin and he said that Garmin told him that it was almost where they could put it in, but right now it wasn't. That's what Garmin told him. So he called while I was sitting there listening to him. But I don't know what the story is. You know, you said one thing and Garmin's telling him something else. So I don't know. You know, that's the reason when we talk, I said, you know, which way you go, I don't know.
Over 500 going into sunny Monaco's Comanche, and there are the.
Well, I put a couple of these Arctic Airs, help some people put those in there. And the only thing we did is we got a hook to the battery, the plug-in that Piper uses for external starting, which I have on one of my planes. You put one in there, and when you run the wire up, you run from the positive bus back there, one wire to flip that solenoid on to put power to it. And he's got a plate you mount in back there that the exhaust goes out the back tail.
Yes, yep, absolutely. A lot of people seem to be using the tail as the exhaust place for the hot air.
Yeah.
Well, Jimmy, it is always a pleasure to have you with us. And I'm going to be hooking you in when we get ready to talk strut housing. So thanks for being with us.
Okay, well, I'll tell them what little I know is be like a BB on a 4-lane highway. It might get lost.
I'm sure. And Jimmy, you're flying what out of what airport?
I'm Chris County, Cordell. I can't call the number right now. And
In Georgia.
My tail number is 8809 Papa.
Good deal. Well, welcome and thanks for being part of our Comanche Zoom tonight.
Well, I try to fit in everything. Knowledge is something you never get enough of.
Amen, sir.
So,
good to see you.
Well, listen, I don't want to hog. I'm going to listen. You've learned more by listening. I've never known knowledge entered the brain through open mouth, so I listen.
Wise men have said that. Anybody else jump in and say any quiet moment, say who you are, where you are, and what you fly.
This is Russ Kelsey. I'm flying a Mooney out of Parlin Field, and I'll be seeing you all Sunday. I'm one of your presenters.
Oh, Russ, welcome and thank you for joining us. This is wonderful.
You're welcome.
So Pete, I missed this. I do want to apologize to everybody. Pete, did you already talk a little bit about what Russ Kelsey and his colleagues are going to be doing on Saturday at Parlin, Sunday at Parlin?
I didn't talk on Zoom about it. I did put it into the information about the fly-in. They are doing a wings program for us. Of course, they're inviting other people that want to come too, but that's all right. The program is, can your aircraft really perform? That's the title. And what they will do is take your POH, your Comanche POH, and walk you through it for that particular day. What is the air density? What is the wind speed? What direction is it coming from? And you have to figure out how much runway it's going to take you to get off for a normal takeoff or for a short field takeoff. And if we get a chance to, how much runway is going to take you to land in your Comanche. We only count the first landing. We don't count the second or third bounce. But they're going to have the runway marked off so you can actually look out and see how well you did. And they are also providing lunch, hot dogs and hamburgers. So it's worth the trip just for that alone. It is also on Sunday because of the weather. It is on Father's Day. And in the notice that I just sent out, I reminded you all that there are 3 extra seats in a Comanche. So bring the party.
So this is pretty exciting because max performance takeoffs and landings is a wonderful subject to be able to do well anytime you want to go into and out of a short strip or on a hot day. So Pete and Russ, thank you so much for putting this together. This clinic is going to be potentially a lifesaver. And I'm looking forward to seeing you all there.
It certainly can
sir,
be.
go ahead.
We've seen some close calls at Parlin. Alan, and which is part of the inspiration for us doing this kind of thing. So yeah, bring your calculators and your pencils and your thinking caps, because we're going to actually have you crunch some numbers. And if you have an app that you have set up to do some of this, that's great too. We'll work with that as well. It should be a lot of fun. And what our real objective is to have you do this book work. And then what's really going to be useful to you is to actually go out and fly it and see how your actual performance compares to what the book said the performance would be. So that's the interesting part, I think, is comparing the two. I'll leave my my impressions from previous seminars and my own experience until Sunday when we have a chance to talk about it. But I think you'll find some interesting trends in the behavior and your book data and what you can actually do on the airplane.
Oh, wow. Well, I just want to say George Merriam, who's with us tonight, but has had a very close call with his health, was originally going to be speaking about max performance takeoffs and landings. And then, George, you ended up with this PIC line thing.
Yeah,
but we're really looking forward to your Comanche Zoom on this topic.
I was planning on a presentation both tonight and on Sunday, but I haven't gotten a doctor's release, and I'm still tethered to a antibiotic. So I'm watching it real close, and I won't get a release until the invasion has escaped my body. So and I probably won't get released for a couple more weeks from infectious diseases and so forth. So Bay State Hospital in Springfield has been a lifesaver in this case.
Yeah,
thoroughly.
I'm sad to
George, this is Russ. We're going to miss you. We were really hoping to have you there with our presentation, because we're just crunching numbers out of a book.
Well, you know what? That would have been my suggestion. You know, I read in a lot of different areas. You can imagine how many people produce right from the beginning flying lessons. We do short and soft field takeoffs and landings. So it's preliminary, but one of the things they look at real closely in the commercial check ride, it doesn't matter what airplane you're flying in, what you're using for short field efforts, you use the POH. And right. So you can say generic things about a maximum performance takeoff and landing, and they all sound alike. But what really is the bottom line is your POH. Right. You fly that airplane based on its performance, and there's going to be a different performance for a 180, a 250, a 260, and a 400, and the twin. Everyone flies that airplane according to its POH and how familiar you are with that airplane. I remember a doctor telling me, you know, your body only is issued so many heartbeats. Don't waste them on the bike trail. I say that about Comanches. You know, we are not the owners of Comanches. We just possess them for right now. We're going to try and keep them in as good a shape as possible to transfer them to the new owner. You can't say they're only issued so many landings, so don't waste them doing short field demonstrations. But the bottom line is, this is not a contest. This is just an analysis of how closely you can come to the performance, but don't try and exceed it.
No, that's exactly right. Yeah, because we would advise you to fly the airplane the way the book says to fly your airplane.
Exactly. That airplane's going to outlast you a long time. You're just the current owner, and the next owner wants to be a happy Comanche owner, because our objective is to keep these Comanches flying. Medically, I don't think we're as strong as the Comanches were made. The Comanches were made to outlast us. And that's our objective, is to keep them flying and then transfer them to their new owners, so with that same thing in mind. Parlin is a beautiful airfield, so much to offer, and I'll be up there just as soon as I'm able, but this weekend is just cutting it a little bit too close for me. I look around at the people that I'm sitting here with, all these faces, and I admire everyone that owns a Comanche and envy the ability to fly them and to own them. I'm in awe of the whole organization.
Wow. Well, George, we couldn't have said it better. Keep your plane in good shape, fly it carefully, maintain it well, find the next person, whether it's a son, daughter, nephew, niece, or a new person to the Comanche.
Right. We age out and then we transfer. So treat them well while you have them.
Amen. Anybody jump into any quiet moment and welcome this evening, say who you are, where you are, and what you fly.
CJ, this is Jimmy again. I did mention to Greg, ask him if he would consider giving a discount to the Northeast Comanche Society for if they wanted to buy them.
Oh, cool.
Yeah, I hadn't got an answer from him, but I have asked him that. So I'll get back out now.
Outstanding. Thank you, Jimmy. That's what we need.
Hey guys, this is Milton Ames. I'm in Tucson, Arizona. I have a 1959 250 Comanche. Put about 25 hours on the last 40 days. Got a chance to fly formation just a couple of weekends ago. So that was good. I was a little rusty on formation, but getting back into it. So got the airplane in the hangar. I'm trying to get it together for my long trip to Oshkosh next month. And after that, spending 30 days in Virginia with it. So it's going to get wet, I'm sure, with all the rain back east. But anyway, glad to be here.
115 degrees today.
Well, it's 118 or so here.
Oh, no.
So Milton, you just introduced like all of our up and coming topics. First of all, welcome and thanks for being part of with us. Second, next week is air conditioners for Comanches, both well-known ones like Arctic Air and some up and coming from some other Houston and Florida and Arizona owners who are innovating. And then just a new thing that nobody knows but me and the rest of the ComancheTown co-hosts. The Thursday before Oshkosh, Randy Heitree, who is actually a Comanche 180 owner and an A&P who's completely restoring this 180, is going to be getting on the Comanche Zoom to answer everybody's questions about parking at Oshkosh and Oshkosh stuff. And if you got your Comanche Zoom invite, you may have noticed a quick intro to what the plan is for this year, because Vintage is expecting to be overwhelmed with vintage aircraft. And in fact, EAA is expected to be overwhelmed with aircraft this year. So we are going to be uncharacteristically organized and disciplined about everybody getting registered. And we're going to need to target getting there early if we can, like Friday, Saturday arrival.
Yeah.
So you're in there, Milton, huh?
Yeah.
You're on it. Good deal. Well, thank you and welcome. Anybody else jump into any quiet moments, say who you are, where you are, and what you fly.
Yeah, we got a couple minutes till we start doing the program.
Mike Ellis, Piper Comanche 250 out of Moline, Illinois.
Good to see you again, Mike. And can you message me on Facebook? I actually need to ask you a question.
Message you on Facebook. I'll have to play with that. I'll try.
Oh, no worries.
I don't use
keep
that.
forgetting. No,
I
you know
don't
what?
use Messenger that much.
I'm going to send you a text then, because I've actually been meaning to ask you a question for a month now, and I keep forgetting. Anyways,
right,
welcome
yeah,
and thanks
shoot
for
it over.
being part of us.
All right, thanks.
Anybody else jump into any quiet moment? Well, we've got them, who you are, where you are, and what you fly.
Hank
Chris
Spellman,
Barber,
Hank Spellman, Lincoln, Illinois, in the center of the cornfields. Identifier Kilo Alpha Alpha Alpha, so it's easy to remember. 1959 Comanche 5903 Papa.
Welcome, Hank, and good to see you again. Thanks for being part of us.
And Dwight, no video here, but just quick out of Ellenville. Thanks for all you that came to Wings and Wheels. I fly a 260B, and I've had it since '92, and it's been the best thing.
Dwight, it's good to have you. Thank you again. For anybody who had missed it, so Dwight did a Comanche Zoom on insurance. He actually has an insurance company that used to do a lot of aviation insurance. And for those of you struggling with it, all the Comanche Zooms are recorded. Dwight's Comanche Zoom is done back in 2020, but you can search the recordings and find it. And Dwight, that was amazing, the Wings and Wheels for Warriors. How much did you raise for disabled veterans?
We just delivered a mock-up check for what the total was of everything, and it was $18,000.
That's wow.
Yep,
Congratulations, and
so,
thank you for what you do.
Yeah. Thank you all for coming. Every bit of participation makes a difference, and each year it'll get better, and it's just a good time. So it's something different for all of us that fly to come and see a lot of cool cars too, you know.
Just as a quick note, the aircraft trophies all went to Comanches.
Oh, all of them?
All of them.
Well, no, that's not true. They all went to Comanche owners. One actually went to a Piper Malibu. So.
Well, all right. I stand corrected.
Words.
I stand corrected.
Okay. All right. I'm glad I can correct you and not get in trouble. I don't get ousted from the group here.
CJ,
Thanks
I
for
have
being
a
with us.
question for Milton.
Go ahead, Hank. Question for Milton.
Milton, what did you say the temperature was today?
Oh, in Tucson?
Yes.
It's about 112 today. I think I said 118, but that's probably where it is in Phoenix.
Oh, okay. I was just thinking that's kind of unseasonably cool, isn't it?
Yeah, we're waiting for the heat wave.
Okay, time for me to put my black hat on. It's past 7:30. We want to get started with the presentation. So I'll give you a quick view again of what we're doing tonight. This is the plan, RSA fuel injection and MSA carbureted systems with Alan Jesmer. This is a bit of how they work and what's involved in it, and if something goes wrong, what you can do about it, and particularly on the spot, what you can do about it. So it's going to be very interesting. And with that, I'll let CJ do her thing.
So I want to introduce Alan Jesmer. And Alan, while you're getting that screen share ready to go, I just want to apologize. We misspelled Alan's name and correcting it in all places. That's Alan Jesmer with one S. Alan is a former U.S. Marine Corps helicopter mechanic and crew chief, been with Precision Airmotive for over a quarter century, has held virtually every hat in the company. We had the privilege of, the Comanche Zoom does a test flight the night before, and Alan's a master. So it is a real pleasure to be able to listen to somebody with that kind of knowledge and experience talk about something that's so essential. The things I didn't expect were the fact that with Alan's information, we'll be able to get full performance out of our aircraft, whether we're flying carbureted or fuel injected Comanches. Some of the troubleshooting and tuning tips also may give us better performance and better efficiency. So I'm pretty excited. Alan, are you good to go with the screen share?
I am ready.
Okay, sir. Well, with no further ado, thank you for being part of us and thank you for educating us.
So I'm going to hit the share now. Let's see what happens.
Pete has mentioned that sometimes it helps to go to speaker view on your device, and I'm going to mute myself.
We got it.
All right.
I would suggest everybody else go to the speaker view. That's in those boxes up there in the upper left-hand corner where they had the big one box. That way the person who's doing the talking will be in your face.
Just what I like doing. I like being in everybody's face. So we're ready to go?
Yep, you're gonna have to hit your plays in order to get the slides to go.
Okay. Well, it's just a slide, right? So yeah, okay, I'll go back. Everybody can see it though, right?
Yep.
Okay. So anyways, thank you, CJ. I want to thank the Comanche community to invite me to come and talk. I've been with Precision, like she said, for 26 years. I've been mostly in product support, and I do a lot of IA renewals and a lot of troubleshooting. I take all the tech calls here at work. And so, you know, if anybody has any issues they'd like to talk about as far as carburetors or fuel injection, I'm more than willing to try to help you. Over the years, the owners have purchased several companies, and in 2018, they opened a new parent company called Tempest Aero Group. Tempest Aero Group, as you notice, the companies listed below is the parent company, or for the associate companies listed, which are Tempest. Tempest manufactures oil filters, spark plugs, vacuum pumps. They do valves, they do other things. And then they've got Precision Airmotive, which who I work for. I'm the general manager here at Precision. We manufacture the RSA fuel injection systems. We bought Bendix back in 1988, so we've owned the Bendix fuel injection for 33 years. There's also Marvel Schebler. When I got hired 26 years ago, we had Marvel Schebler and the RSA. I'm going to talk about Marvel Schebler tonight. We also have Alcor, which is all the temp probes and all the kind of those kind of sensors that we sell. And we also have Stratus. But they call us the Tempest Aero Group, but we are individual companies and we still operate as individual companies. I'm going to start out a long time ago, and I'm sure all you guys remember this when the Wright Flyers took flight in 1903, when the pilot had no control of the engine. When the pilot was ready to take off, they set the engine and set it to full power, and then they took off. When the pilot was ready to land, he cut off the fuel to the engine and he glided to a landing. And, you know, I've heard many people complain about dead stick landing. They did a dead stick landing every time they flew. So from 1903 to about 1910, the Wright brothers finally installed a carburetor in their engine. The addition of the carburetor allowed them to control the engine power. So I think the Wright brothers probably have the first carbureted engine in the US back in 1910. So that brings us to the Marvel Schebler line. And Marvel Schebler was formed back in the 1930s, and they manufactured, anybody who's got John Deere tractors, they manufactured the MA2 carburetors, they manufactured ground power carburetors, and they also manufactured the aviation carburetors, which I'm going to talk about. Marvel Schebler was around for about 50 years until they sold it to Facet Aerospace in 1982. So Marvel Schebler sold to Facet in 1982. Facet took the Marvel Schebler name and they started to incorporate the word Facet into their bowls. So you're going to see a Marvel Schebler, you'll see Facet, and they only had it for 8 years. And then in 1990, Facet sold Marvel Schebler to Precision Airmotive. So we bought it in 1990. We owned it for 18 years before we sold the line because of litigation. We sold the line to Volare. Volare was a company that was formed to supply and support the Marvel Scheblers. Volare was only around for 2 years, and they decided to take the name Marvel Schebler and go back to Marvel Schebler. So today it's back to Marvel Schebler aircraft carburetors. So it made that full circle over the last, 50, 60 years. And it went from Marvel Schebler, Facet, Precision, Volare, back to Marvel Schebler. So today it's Marvel Schebler. We manufacture 3 different series or sizes of float carburetors. We manufacture the MA3s and MA4s. These go on the Continental A65s all the way up to Lycoming 0320s. And then we manufacture the larger MA4-5s, MA5s, and MA6s. These go on 360s to 0540s. And those 2 carburetors are updraft carburetors. So you have an air box and you have the air come up vertically up into the intake. Then we also manufacture what's called a horizontal carburetor, and we designed those and built those for Lycoming only, and they go through and on engines 0320s to 0540s, and they're Lycoming only. But you notice that they're now horizontal. The air comes horizontally, and that's for more tightly cowled airplanes. So Lycoming needed a smaller profile of carburetor, so the HA6s were designed at that time. There's 3 different sizes, like there's 3 different series. There's also 3 different conditions you can buy when you buy a Marvel Shebler. You can buy it new. New means it's built to new specs. It's never been installed on an engine, and it costs more money because it's brand new. You can order a rebuilt. A rebuilt is, you see it like the new, it's built to new specifications, except we can reuse parts from cores as long as they meet new specs. They cost less money. If we build a fuel control, whether it's a carburetor or fuel injection, and we built it up all the way and we have to use a lever or a fitting that came off a core, we can't call it new, we have to call it a rebuild. So you may get a brand new unit, but it only has, you know, a used fitting in it, which is, they get replated and they get reinstalled, so they're just like new. So a lot of people say, hey, my fuel control looks new, and a lot of times they are new because they're built the same. Then we get down to the overhauls. Now the overhauls are allowed bigger service limits or higher tolerances, larger tolerances, so we can actually reuse more parts. And that's where overhaul comes in. All of our fuel controls, doesn't matter what condition they are, they must meet factory new flow specs. We don't have an overhauled flow spec. We don't have a rebuilt flow spec. We only have a new flow spec. And something about the carburetors and the fuel injection, Lycoming owns the type certificate to these fuel controls for the fuel flows. We own the manufacturing rights to manufacture these fuel controls. So Lycoming dictates to us what flows are going to go to what fuel control. The flows are determined by what the parts list number is of the fuel control. So when you call up, that's why the first thing we need to know from you is what is your parts list number of your fuel control, because that tells me what fuel flow schedule you're on and how it should be flowing and how many gallons an hour you should be getting and all that type of thing. Now, when we flow test a fuel control, there will be limits. There's rich and lean limits for each stage. We'll take a throttle position, maybe 5 or 6 or 7 positions all the way up through the throttle range, and we flow test it at those points, and they have to meet the Lycoming or the Continental flow spec, so we can match them up. We completely support the Marvel Sheblers. Anytime you see a kit, whether it's a float kit or a major kit or minor kit or throttle kit, it will be associated with a service bulletin or a service information letter. And the purpose of that information is to explain what the kit is and what it's used for. So it's pretty self-explanatory. Here's one of the biggest things that we try to teach people is how to troubleshoot their aircraft. One good thing about a carburetor is if you want to know if it's running properly, if you can lean it and get an RPM rise before it falls off, and if you can pull the carb heat and you get an RPM drop, if you can get those 2 things, that means your carburetor is running the way it should, because it's in the middle of the flow spec where it needs to be. Usually a fuel control, no matter if it's fuel injection or carburetor, you either have a lean problem or a rich problem. Either you go to lean it and it falls right off, that means it's lean, or you go to lean it and it gets a really big RPM rise, that means it's rich. So we start troubleshooting different parts of the fuel control to isolate the component that's affected. We send out a troubleshooting chart with every fuel control that we ship. And I think probably 2% of all people read their paperwork when they get it with the fuel control. But it's a troubleshooting chart. And if you notice this troubleshooting chart that's sitting up here, for instance, on a rough idle, that could be due from a misadjusted idle mixture, and that's on the carburetor. But if you look at the next 3 items for a rough idle, you got bad or leaky primers, cracked primer lines, intake manifold leaks. These are all things that will make you run rough and that you need to check. The number one reasons why engines don't cut off cleanly, a carbureted engine, is a leaky primer. So we tell people, you know, cap off the primer and then go try it and see if you get a clean idle cutoff. So there's various things on the fuel controls that we troubleshoot for. Every fuel control has a idle circuit and a main metering circuit. And every fuel control, doesn't matter if it's a Stromberg carburetor or a pressure carb, fuel injected, or Marvel Schebler, they all transition from idle to main jets around 12 to 1500 RPM. Right in that RPM range is where you transition from your idle circuit to the main metering circuit. And when you adjust your idle mixture on any fuel control, what you're trying to adjust is the mixture. So when you go through that throttle range of transitioning from idle to main jets, you want it as smooth as possible. And that's why you're trying to make the mixture adjusted properly. It helps go through that throttle range. Usually too, I was going to say, on if you can't get below a certain RPM, like you can't get below 900 or 1000, that's pretty much a good guarantee that you've got an intake leak, because you're sucking air into the intake and it's not allowing the carburetor to control your speed down below that RPM. So when anybody ever calls us up and says, hey, I can't get below 1000 RPM, that's a guaranteed it's an intake leak. So on the bowl assembly that's up here on the lean side, to cause it to run lean, intake manifold leak, that's not on the carburetor, that's the intake. And then you have a plugged idle tube. This little idle tube right here is about 1 inch long, and I'm going to show it in a couple slides, but it's about 1 inch long, little brass tube, and it has a bleed hole on the side of it. This is your fuel is determined by this tube, and this runs your idle. So this runs your engine from low idle up to 12 to 1500 RPM. Once you get to 12 to 1500 RPM, the engine's sucking a lot more air now, so it starts drawing the fuel out of this main nozzle. So that's the transition. So the next item for the lean is a blockage in the bowl vent. This vents the bowl, so you have ambient air, and it doesn't allow the fuel. It allows the fuel to run smoothly out of the bowl. If it's plugged up, you actually create kind of like a vacuum inside your bowl, and it doesn't allow the proper amount of fuel to get in there, and you'll have issues with that. Blockage in the jet. So the main jet, if you have a blockage down here, this main jet comes down, and then your mixture valve goes down in the sleeve right here, and they kind of meet like in a V formation. So if you get any fuel that's been sitting or it starts to varnish or whatever it does down in there, you get debris in there, it'll cause a blockage in the main jet, and that'll cause you to run lean. That's the whole purpose of the drain plug on the carburetors, to drain the contaminants out of the bowl, because the bowl always has fuel in it. I like to tell people this is just like the back of your toilet. It works the same way. The float opens, fills up with fuel. When the fuel comes in, the level goes up. The float floats up and it shuts the valve off. So you want to keep it clean. Of course, carburetors don't like sitting. Nothing likes to sit. So once this sits for a long time, what happens is the fuels form acids in the fuel, and it's the acids that cause corrosion from fuel breaking down over time. So if you're going to have these out of service for a while, you should drain the bowl. It's only a recommendation, but you should do that. Broken primer lines, that'll also cause you to run lean. Now we're going to go on the rich side, which will cause you to run rich. Leaky primers, that's the #1 reasons when you can't get an idle cutoff, a clean idle cutoff. We're going to tell you to cap off the primer first before you start looking at the carburetor. When you get to the carburetor, the very first item to look at is this accelerator pump check valve. Now it's a check valve. The pump plunger goes in this hole, and when you accelerate it, the plunger pushes the fuel down and it forces it up this little discharge tube here. Now when the plunger's down, so now when you go back to idle, the plunger is pulled up and it sucks the fuel through the bowl through the one-way valve and fills this back up. This check valve has a spring and a shaft in it. And when it gets weak, it starts to just siphon fuel, and it siphons it right up through this little discharge tube right into your intake. So it leaks. It's not holding the pressure because the spring got weak, and then you'll have a rich problem. But that's the #1 thing on a carburetor that will cause you to run rich.
Alan, this is CJ. Just want to jump in with a point of advice. If you are here with a smartphone or an iPad, you should be able to zoom in on your screen by using the pinch capability so that you can really get a look at some of the finer details here. Thanks, Alan.
You're so smart, CJ. I wish I had you with me all day. I don't know half this stuff that you know.
Lottery will get you everywhere.
Yes, I like you a lot. The tab washer is what it anchors this nozzle in, and if any of those tabs are bent out, what happens is the fuel coming up, or the air coming up through this throat, your intake's down here, but the fuel comes up through this throat, and if any of the tabs aren't bent down all the way, it disrupts the air enough so it won't atomize the fuel. And if the fuel doesn't atomize, it actually causes a rich condition. I've actually talked to a couple of old guys, and I know there's no old guys out here, and he said, hey, you know how I make it run rich? I go, how's that? He goes, I bend 2 tabs up and it runs richer. I go, what? You gotta be crazy. So we actually did that. We bent a couple tabs up and put on the flow bench, and sure enough, it made it richer. But we highly do not recommend you do that because that'll cause other issues. This is the top half of the carburetor. We were looking at the bowl. Now this is the throttle body part. This is the top part. Looking at it, you can tell where the float, is hollowed out here for the float. Here's your pump plunger. The pump plunger also has an adjustment on the outside. This is external, and you can adjust the throws of the accelerator pump to how much fuel you get when you accelerate. Here's the seat for the needle and seat. This is your mixture valve. You really can't see it very good. This isn't a very good picture, but here's your venturi here. Anyways, here's your fuel inlet here. Here's a throttle shaft up here. On the 4-5 carburetors, or the 360 carburetors, they actually have the accelerator paint. It's external on the smaller carbs, but on the bigger carbs, it's internal. It's inside the carburetor, and the linkage comes down through here on the carburetor, and there's an O-ring on the throttle shaft. This is the throttle shaft that goes through. There's an inner O-ring and there's an outer O-ring, and it's pretty weird because if the inner O-ring is no good, you're going to run lean. If the outer O-ring is no good, you're going to run rich. And it's kind of weird how this works, but we're getting into another part of the carburetor of troubleshooting. Usually this is going to happen around cruise, somewhere around above idle and cruise. And then as we move forward here, see, and here's a 4-5 carburetor. This is a 360 or 180 horse carburetor. You notice that this butterfly is not vertical. It's not straight up and down. This is at full power, but it's not straight up and down. And the reason for that is most of these carburetors were designed not to open vertically. They'll open 7 degrees before vertical. They'll open 5 degrees before vertical, but they don't necessarily open full straight up and down. And the reason I show this carburetor is a gentleman called up and he says, when I go to full power and I pull back slightly on the throttle, I get 300 more RPM. And I said, well, did you do anything to the carburetor? And he said, yeah, I had to ground the stop down on the throttle because the butterfly wasn't opening up vertically. And I said, well, you just bought yourself a carburetor because not all the carburetors are going to open vertically at full power. So it's just something to show people to say, hey, these don't open all the way all the time. A little float history. The float started out as a brass float back in the 30s, which worked pretty good. They actually went to a stainless steel float for a little while, but they were so expensive, so they discontinued and went back to a brass float. Those brass floats went for years until the 60s, the early 60s, when they introduced the composite floats. Now, the composite floats were a composite outer layer with a porous center. So if it wore the outer layer off, the fuel would get in and absorb into the porous part and it would sink. And this happened when they introduced unleaded auto gas in the 70s. So the composite floats went from the 60s to the 70s. They introduced auto gas. They started eating the outer layers of those composite floats and they started sinking. So they went back to the metal floats. During the metal floats again, they came out with this product improvement, which is called Delrin. Delrin is a plastic and it was used since the 50s for needles and seats in carburetors. So they decided to use it for floats. But the problem with these, as you can see, this is fuel. That dark color is fuel. This dark color is fuel. Here's some fuel here. So fuel can still get in them because they're hollow. And we used to take the body of this float, take the cap and hold them, and a hot plate would come in between and heat it up just to about a gel state. Then the plate would go away and they'd slam them together and weld them. And we would test them, we would pressure test them, we heat test them, and they'd pass all our tests. And then if there's a little pinhole, you fly up to altitude, that little pinhole gets bigger, fuel goes inside, you come down and it seals up again. So it wasn't a perfect float either. About 12, 13, must be 14 years ago now, we came out with this blue epoxy float. This float has been a very good float for us. It does not sink, it does not absorb fuel. It won't absorb any chemicals that we put in there, carburetor cleaner or whatever. It does not sink and it does not absorb fuel. That's why it doesn't sink. It's solid epoxy. If you watch the video on Marvel Shevler's website, MSACarbs.com, they actually drill holes through it. They actually cut half of the float off and it still floats. So it's been a really good float. We've had zero problems with it. So we're very happy, and we definitely feel that every carburetor should have this new epoxy float in it. It also has a stainless steel clip also, so it's a lot more durable than any other float we've had. Here's the little idle tube. Remember, I was pointing that out. It's about 1.5 inches long, and it's got a little air bleed hole in it. And the fuel comes up through here, and it bleeds air in here, and that mixes with the fuel, and you have your fuel air mix come up through your idle circuit and run your idle circuit. Another troubleshooting part on this is only torqued in at 3 to 5 inch-pounds, and guys love to reef those things in, and when they tighten them way too tight, you can actually collapse the end of this tube because it's only brass. So when you collapse it, you go from a normal mixture to a lean mixture because you're collapsed the end of that tube, and it's going to be excessively lean. This is where the drain plug goes. You don't want to over torque it because it's a pipe thread, and if it cracks, we don't have any approved repair for a drain plug thread because it's too big, and to put a helicoil, it's too big. You know, we don't have a weld repair or anything like that for them. So be careful and use proper torques. The reason why I say that too is remember what materials we're using. We're using brass and we're using aluminum in both these fuel controls, both the fuel injection and the carburetors. The problems with these materials is they're soft. You over torque brass, it's going to stretch the threads, and then the threads are going to crack, and then eventually they're going to come out. It's the same with the inlet fittings too. Like on the fuel injection, they're big aluminum threads, and you can over tighten them over and over and over. You do the same thing. You stretch the threads, you crack the threads, and then all the threads come out with the fitting, and then you call us and say, hey, all the threads came out with this fitting. What do I do? And the first thing I say is, what did you torque it at? Because I know you've been over torquing it a lot, and it's got to be very well over torqued, you know, to do that to it. And I know people want to tighten things extra tight so they don't come loose, but if you use the proper torque, you shouldn't have any problems at all with it. Here's another unapproved drain, you know, JB Weld, all that kind of stuff people love using to try to repair things with, and it's just not recommended. We don't recommend it. The tabs on the screws for the bull halves, when you put a bull half together, you got to make sure they're all bent down and make sure that screw's locked in there. Just simple things. Airbox studs, your studs go in the bottom of the carburetor for your airbox to connect to. Please, again, over torquing. You notice this guy punched it right through the boss of the carburetor. So you got to be careful of that. This is a mixture, and you notice there's a big divot, a big dent in here in the carburetor. This is from pulling back too hard on the mixture. When you go to shut your engine down, you really pull it back so it'll shut down, but you really don't have to do that. Just easy until it hits a stop and let it go. A lot of people really reef on that thing and can actually start going backwards. And what I mean by backwards, this sleeve right here is where this mixture valve this is connected to it fits into this sleeve. This sleeve has a slot in it, and the mixture valve that slips in there has a slot in it. So when you turn them and they even up, the fuel goes through there and comes up through there and comes up through the main jet. When you go to lean it out and shut it off, that solid part of the valve comes around and shuts off these slots, so you have idle cutoff. If you wear too big of a divot into this carburetor, into the boss, the valve that's in here will actually start going reverse and start making you rich again. So you can't go too far because you start opening it the other way. So it's very important that you don't reef on the mixture when you're trying to shut your engine off. This is just, getting, unapproved repairs, grabbing a regular screw out of the shop. It's got a different thread. He probably cross-threaded it. This little wire here, it's usually music wire, which is very strong, and you can see it right here, but the screw goes through this, the lever goes on. This is your mixture lever. But the lever goes on, the screw goes out, and it indexes it to this mixture valve. Well, he just used a soft piece of copper and didn't really understand what it was for. So when you turn the mixture valve, you start wallowing it out, and pretty soon your mixture's not working. So it's just another thing that we find that you don't want to do. You don't use the proper parts. Okay, now we're going to get into the different troubleshooting of a carburetor. Like I said earlier, there's two circuits. There's a idle circuit and a main metering circuit. This is the idle circuit on a carburetor. This right here, that's the whole circuit. This is running your engine below 12 to 1500 RPM. Above 12 to 1500 RPM, the fuel starts coming out of the nozzle and your venturi starts working and everything. But below that, this is where your fuel is. You're running. So it comes up out of the bowl, it goes through that little idle tube I mentioned, and the idle tube, whoops, I'm sorry, I screwed up. The idle tube determines your fuel flow for that carburetor. It comes up the emulsion channel and it goes behind the mixture screw and then comes out in the throat of the carburetor. If you look in the throat of the carburetor by the butterfly, you're going to see different pinholes. As you try to start to accelerate it, it opens up these pinholes and allows more fuel in. About 12 to 1500 RPM, you're drawing so much air, it starts drawing the fuel out of the main nozzle. So if you're running lean or whatever, you could actually adjust this idle tube to change the flow. But we want to do it on a flow bench. We don't want people drilling them out and stuff because it only takes a couple hundred thousands or a couple thousands, excuse me, to change it from a rich condition to a lean condition to a rich condition. When you adjust your idle mixture, you're adjusting your mixture to get 25 to 50 RPM rise at idle cutoff. So when you pull the throttle back and it starts coming up, you want it to go 25 to 50 before it falls off. That is an optimum RPM rise, and that's how you want to adjust your mixture to get that 25 to 50. Anything below 75 RPM rise, we think is okay. If you go to idle cutoff, you pull your mixture and you get up over 100 and then it falls off, you're too rich. You got to lean it out. So that's what the mixture is for, and it helps you again through your transition from the idle to the main jets, which is 12 to 1500 RPM. Okay, now from the idle, here's where the idle system was going up through here. And now we're talking about the main metering. This is above 12 to 1500. This is 1500 up to full power. It's now coming out of here. Here's a different area of the carburetor to troubleshoot now. If you're having cruise problems, full power problems, you're not getting enough fuel. It's going to be determined by this nozzle is what the fuel flow is going to be. All the fuel flows are determined by the parts list number of the fuel control. Each part number has its own flow schedule. So if you have say, I know your Comanche guys got a lot of fuel injected engines. You call me up and say, hey, I want to get this many gallons an hour. Well, I can put so many gallons an hour, but I can't go out of that flow sheet that Lycoming has to be legal. We could put 50 gallons an hour through a servo. The servos or the fuel injection that you guys have on your 320s, those servos are used on 150 horse all the way up to 260 horse, that same size servo. We just calibrate it to what the power is you have and the parts list number. And we can't go outside that realm. There are lean and rich limits that we can flow to. So if you're running, we just helped a guy with his Comanche, and his was at like the middle of the flow spec at full power. We put it to the rich side for him, and he's happy with it. So it doesn't take a lot to change the flow. Here's the accelerator pump. This is a 360 or 180 horse carburetor, but the pump plunger is internal. Here's the linkage. I'm going to talk next about this economizer. It's another part of the carburetor to troubleshoot. And this is the economizer. It's called a mechanical economizer. This is your throttle shaft, and it has a tab sticking out. When you go to full throttle, this tab comes in and pushes this air metering jet and shuts off all the air. So when you're at full power, you're at full rich. As soon as you start pulling back power into cruise, it opens this bleed hole and bleeds air down into the main jet for economy. If you're having an issue of lean or rich during cruise, this could be your culprit. If you have a 180 horsepower engine, it might need to be readjusted. Sometimes this tab will actually wear a big divot into that air metering pin, especially if that carburetor has a lot of hours on it. So each thing, we're going to help you troubleshoot. What RPM are you having trouble at? Are you having trouble at full power? What happens when you lean it? What happens when you pull your carb heat? You get an RPM drop. I mean, we try to ask all those questions to try to narrow down where your problem is exactly. The other thing we'll do for you too is we're a very nice, friendly company. We actually flow test carburetors and fuel injection for people for free. We don't charge anything to do it. So if you suspect you're having a problem, you get an RMA number from us. You just fill out a little form about what you're sending us and what the problem is, and then we'll flow test it, and we'll call you and tell you what we find. So it's a good service that we do. I mean, it just lets people know, what's going on, and it also helps eliminate the problem if they think it's a fuel control and it's not. We can also help with that too. Okay, Mark Keeney, he's in Burlington, North Carolina. That's where they build the Marvel Chevrolet float carburetors. But Mark's been with the company now for about 12 years, and he's the tech guy. He's very good with it. He's a good guy to talk to. If you call these people and you're never happy with them, you're not happy with them, you can always call us. I got Peter Nielsen that's worked here for 30 years. I've been here 26 years. We were with the carburetors for 18 years. So we've got a lot of experience. So we've got, and we got a lot of support. So if you call us, you'll actually talk to somebody. All right. Do we want to take any questions right now, CJ, or do you want to wait?
I would say I think there are a couple in the chat window, and then just open it up for anybody who wants to ask questions for a moment on the carburetor area. A couple of questions. You had mentioned needing to empty the fuel out of a carburetor float bowl if the airplane is going to be sitting for a long time due to the fact that fuel will break down and create acids. And how long is a long time?
Well, it depends. A lot of people use auto gas, and it doesn't take long for auto gas to start breaking down. We recommend if you're going to have, auto gas, I mean, we've got to remember, we don't tell anybody they have to do anything, but it's kind of funny to me because our manual says if you're going to be down for more than 30 days, you should pickle the fuel injection system. So we know that's not going to happen.
Right.
If you use an auto gas, we know you're not going to pickle your carburetor, or we know you're not going to drain the float bowl. Probably not. You probably wouldn't do it for months. Put stabilizers in your fuel if you're not going to fly for a while. They have fuel stabilizers for auto gas. So you should put some stabilizers in your fuel. But I mean, auto gas, I can't tell you a window of when it starts to break down, but I know it does. It's
so with
probably 6 months
Comanches,
what's that?
with Comanche drivers, they rarely, if ever, use auto gas. So in the case of avgas.
Yeah, avgas well, avgas, it depends. I mean, if you got fuel injection and you're using avgas, you're only maybe a tablespoon of fuel's in the servo. So you don't really have to worry about it. And all the parts that are in the servo are not going to get hurt because they're silicone impregnated diaphragms, they're Buena rubber O-rings, and they're good against the gas. So you're not going to have any problems, sitting a fuel injection for any amount of time. The carburetors, if you're going to use avgas, I mean, and let it sit, I believe there's still stabilizers for avgas that you should probably put in if you know you're not going to be flying for a while on a carbureted one. So.
Cool. Are there any, and Chris just commented that even non-ethanol will mess up a carburetor that sits.
Yes.
He mentions his 320 carb is not running right now after that a few years.
Yeah. The Brazilians, they use 100% ethanol in our fuel injection. They've been using it for about 12 years, and they're starting to have corrosion issues with the aluminum of the servos. you know, and they're asking us, what are we going to do about it? I go, well, there's really nothing you can do about it because the ethanol just loves messing with aluminum. So,
Ethanol and water together will I call it ethanol water. You take 100 cc's of gasoline and you put in 20 cc's of water. If the amount of 80 cc's gasoline, 20 cc's of water, shake it. If the water goes up to maybe 30 cc's or 29 cc's, it's got that 10% ethanol in it. And
Right.
that water ethanol mixture is very, very corrosive. It will take the copper out of brass jets and deposit it on the inside of the bulb carburetors.
yep.
So
Yeah. So anyway, yeah, I mean, call us anytime if you have any issues. We even are known to talk about personal issues for you older guys. I'll get into are we done? All right, I can go to the fuel injection now, or is there another questions?
We've got two more questions.
Okay.
One is, could you talk about the enriching circuit and what it does? Now, this is from Lonnie Wallace. He pulls back a 1/4 inch and gets a 1/2 gallon per hour reduction and much closer EGTs.
And this is on 180 horse.
Lonnie, go ahead.
It depends what carburetor it is. Is it a 160 horse or is it 180 horse? What horsepower is it?
So Lonnie and Lauren, you'll need to unmute to clarify. Or you'll need to chat back in. But I think that all of us would be interested in the enriching circuit.
Yeah, basically all the enriching circuit is bleed air. That's really all it is. You're bleeding air in, and that pin that I showed you, this pin right here, it's on a ratchet and it's set. There's a certain setting it's got to have, and it goes a certain distance, and it's on a spring. And basically, it's just designed to help with economy of the engine at cruise. And all it does is bleed air down into the main jet. These can be adjusted, you know, depending on what you're running or what problem you're having, especially if it's in cruise or right below full power in cruise. If you're having, now I heard you say he pulls back the throttle just a little bit and it does that. I'm curious.
So he mentioned it's a 180 horse, it's a Comanche 180.
Okay.
And he said it was, he's pulled back a 1/4 inch and gets a 1/2 gallon per hour reduction and much closer EGTs.
I would start questioning him. I would start asking him how many hours are on the carburetor. Because like I mentioned, this little tab on that throttle shaft will form a big divot in there. And if that's the case, it'll push it. And then as soon as you back off, it'll kind of spring back. It'll spring back further than you want it to. So
yeah, hi, this is Lonnie. It seems to be common wisdom, or that pulling back somewhat will equalize the EGTs, and I experienced that, and also experienced that 1/2 gallon reduction in fuel flow.
Yeah, I would like to ask my engineering manager, because I'm not versed on that and I don't want to misinform anybody, but I'd really appreciate it if you'd call me about it.
Yeah.
Well, my understanding is the butterfly being more askew gives better distribution to the cylinders because there's more turbulence.
Right. Yeah. So, and there's some carburetors, like I said, that most are vertical, some are 5 degrees, some are 7 degrees. So it's all dependent on that. But
and Alan, yeah, if you do that, we've had Garmin and other companies come back when we have questions like this. And what we do is we post the answers with the recording and we'll stick it out where people can see it, and then everybody benefits. So if you can do that,
yes,
and your engineering comes back and says, yeah, because I had heard the same thing Lonnie did, that if you just creep your carb out, is it your carb heat, Lonnie, or is it your mixture?
I thought it was a throttle.
No,
No,
you're right. It is
the throttle, pull the
Yeah.
throttle back about a
Yeah,
quarter of an
throttle.
inch.
Yes, yes. Sorry, guys, I'm being silly. Yeah, what Lonnie said, we've heard that and we always wondered, like, is this true and does it really work that way? So it would be amazing to have your
Well,
technical guys.
there's probably a very easy and simple explanation for it, I'm sure.
Awesome.
Yeah, and I'm gonna check with our engineering manager, but I'm almost inclined to answer it, but I'm not positive, so I want to make sure that I am before I
Okay, cool.
answer.
And then Alan, do you want to go ahead and unmute since you've got your hand up and go for it?
You can still hear me, right?
Yeah, we can still hear you. Alan had his hand up with a question and I'm just
Oh,
telling him to
another
go
Alan?
ahead and unmute and ask it if he wants to.
Oh, another Alan.
A different Alan. Yeah, sorry.
Hopefully he spells his name A-L-A-N. That's the correct Alan spelling.
He actually does.
Oh,
And then
good.
while he's finding his unmute button, I'm going to ask one other question, which is, can you talk more about being too aggressive with the mixture? You mentioned if you're too aggressive, I think you said if you're too aggressive with the mixture, you can actually do something not so good.
I think it's more too aggressive with the throttle.
It was the throttle. Okay.
Yeah, there's actually surface information out there that people love to fire all forward the throttle as fast as they can. The carburetors don't have time to catch up to that throttle response. So that's why they say you should do it in 2 to 3 seconds instead of just wham. You know, slowly feed the throttle in so it can catch itself up. Remember, it's got to go from the idle circuit to the main jet. And if it's not set up properly or perfectly, it will hesitate. Most engines, especially 360s, hesitate through that range. So if you're sitting there and really forward in that throttle real quick, it may make even quit. So you want to do it slow, firm, but not too fast. And there's actually service information about how fast and how fast it should take, or slow, I guess. I think it's 2 to 3 seconds or something, but to me, that's pretty fast anyway, but you just don't want to jam it forward because you got to get through that transition and you want to do it while the engine's still running.
Yes. Yep. And actually just a quick heads up that, and Craig Hammond pointed this out, believe it or not, most Comanches, they built 7,000 Comanches. I think it was roughly 5,000 singles and 2,000 twins. And oddly enough, if you go through by model year, a slight majority of Comanches are actually carbureted. So you've actually got the attention of a lot of Comanche drivers. Yep. You know, we're about, let's just call it half and half. And then Kurt just chimed in and said, you had mentioned that if people pull back too hard on the mixture, it can damage the carb body.
Yeah, yeah,
right?
Yes. And that's the other thing. It's mostly happens with flight training schools that pull the mixture back too aggressively. In fact, that carburetor I showed is from a flight school where they're training and they're constantly pulling back on it. But if it goes too far, it starts opening the other way. So instead of going idle cutoff to idle cutoff and staying there, it actually goes beyond idle cutoff and starts getting richer again as you try to pull it harder. So only pull it to where it's adjusted to the stop and don't try to pull it any further.
Oh, interesting. Okay.
I'm gonna make a slide next. Now I know I need a slide to show the mixture valve is that little brass valve and it's got a half slot cut in it. And then the sleeve it fits in is stainless steel and it's got a slot cut in. So this is a slot, you bring them in, that's open. As you turn it, you shut it off. But if you go further, you open it again. So this is off, this is rich. You pull back too hard and it starts going back the other way.
Oh, interesting.
So,
and did you just say in a carbureted airplane that if we go from idle to full with the throttle too quickly, we can actually cause the engine to stop or at least stumble?
If the mixture isn't adjusted properly.
Got it. It's a good thing to check before we do our go-arounds, huh?
Yeah, it's like I said, 360s, 180 horses are notorious for hesitating on acceleration. just naturally. It's hard to get them dialed in perfect with that mixture. That's why that 25 to 50 RPM rise of idle cutoff is so important, because you don't want to have it so you're going to have issues going through that transition point.
So we should, and the reason I'm bringing this up is, although we don't do go-arounds too often, in fact, at a recent Comanche Zoom, we were commenting we probably should practice them, since it's kind of, you get real busy if you do have to go around. You're mentioning that one thing we should check on the ground every so often is when we bring things back, we should look for that RPM rise at idle cutoff and if we've got that, it'll confirm that when we go to slam the throttle forward in an emergency, we're going to have a smooth response and get off
right
when we need to. Okay,
yeah.
Good safety tip. Last question. This is from a fuel injected driver. Maybe you'll be getting into this. Is there a way to check a fuel injected system for contamination after being left idle for a long time?
Yeah, you can take the fuel inlet screen out. You can, take the nozzle out of the cylinder and inspect it. You can blow the lines out and see if there's any contamination in it. Mostly you're going to see it in the fuel filter and the inlet filter of the servo, if there is. Sometimes it's small enough to go through the filter and get out and clog up the nozzles, but you're going to notice it when the nozzles start getting clogged up and you have a lean running cylinder and 3 richer cylinders, which I'm going to talk about. But yeah, there are ways to check.
Good deal. Well, on to fuel injection, because you do have a whole bunch of fuel injection drivers here. And Alan, with your iPhone, who raised your hand, just feel free to jump in if you're still there, but otherwise on to fuel injection. Thank you so much for getting us through carburetors and teaching us.
Yeah. And like I said, call me anytime. I'm more than happy to talk to people, and you'll actually talk to me. When you call up, we're here. We're not Lycoming or anybody else will go, yeah, we'll be back to you in a week. Anyway, so fuel injection systems, a little history on Bendix. Prior to 1988, this fuel injection system was owned by Bendix because Bendix designed it back in the 50s. That's what kind of cracks me up is, what technology would you like? Would you like an earliest technology, a 30s technology of a carburetor, or would you like the latest technology, the 50s? It's pretty weird in aviation. I mean, we came up with an electronic system and everybody was freaked out because it didn't have a mixture. So we put a potentiometer in with it so they could override their mixture. And that's how everybody's feeling about having electronic ignition and an electronic fuel system in their airplane. But it just kind of cracks me up. It's kind of ironic. So anyway, Bendix started out with the Bendix Strombergs. Everybody knows of the little black Stromberg carburetors that are on the little Champ airplanes, and they go on the A65s all the way up to 1340 radials. And it used to be a competitor of Marvel Schebler back in the good old days. Bendix went a different direction though. Bendix came out with a pressure carb, and a pressure carb uses 2 diaphragms, an air diaphragm and a fuel diaphragm, to meter the fuel. The pressure carb still has the nozzle that shoots the fuel air up through the intake, but it uses diaphragms to meter that fuel. The 2 advantages with a pressure carb over a carburetor, a float carburetor, is, first of all, you don't have a float bowl, so you're not storing any fuel, so you can mount it in any attitude you want, but don't put it in a bad attitude. And it's not storing any fuel, so it doesn't care how it's mounted. You can mount however you want. The second thing is carb ice. I don't know if you guys are familiar with carburetor ice, but in a float carburetor, Marvel Schebler or a Stromberg, the nozzle is shooting the fuel air and the venturi sits above the nozzle, and you got the butterfly sitting above the nozzle. So all this fuel air is hitting everything, and it's designed that way to help atomize the fuel better. In fact, if you do your accelerator pump, you should not see a big squirt of fuel shooting up to the ceiling. It should be hitting the throttle shaft, so it helps break it up. But The fuel air is below, hits the venturi, the butterfly and everything. That's where your carb ice forms, is all around the venturi and the throttle valve, the throttle shaft. On a Bendix pressure carb, all they did was it minimizes carb ice because they took the nozzle and they moved it downstream of the butterfly and the venturi. Now you don't have a bunch of fuel air hitting the butterfly and the venturi and everything. Therefore, you minimize carb ice. And that's in a pressure carb. The first fuel injection system, the RS fuel injection system, they just took that metered fuel, and instead of setting it up through the intake, they now send it out to a flow divider or splitter and then out to each cylinder. That's when we call multi-port fuel injection was born. That means it goes to each cylinder, so it's multi-port. It still had, like the pressure carb still had a return to tank line, and so did the first RS system. They required a return to tank line. When they introduced the RSA system, the system that we use today, we've used for decades, they eliminated the return to tank line. And when people ask me, what does RSA stand for? It stands for inline stem type regulator injection. It doesn't mean regulator servo aviation. These letters really have no meaning at all. This is what it stands for. RSA equals, in the manual, it says RSA equals inline stem type regulator injection. And what that means is there's an air diaphragm and a fuel diaphragm. There's a stem, and both of these diaphragms are connected on a stem. And on the end of that steel stem is a steel ball that sits in a seat. Then you have parameters on each diaphragm that are working against each other to lift the ball off the seat and meter the fuel, which I'll talk about here in a second. We manufacture 3 different components of the fuel injection servo, or the system. We manufacture we call them servos. The servo's job is to meter fuel, and it meters fuel very precisely. They don't meter fuel real well at idle because you don't have mass airflow yet. And they start metering very well when you start getting airflow through it. But they're very accurate in what they meter. When it gets metered, it goes to the flow divider, and the flow divider's job is to divide the fuel evenly to each cylinder, because the fuel lines come out of these holes and go to the cylinders. And it also gives you a clean idle cutoff. So this meters, this divides, and it goes out from the fuel lines, it goes out to what we call air bleed nozzles. If anybody calls these injectors, I correct them because they're nozzles. They don't inject, they just squirt, just like your hose does at your house. It's always squirting. The nozzles are always squirting all the time. This is determining, the servo is determining how much fuel to squirt. This squirts right above the intake valve. And then as the intake valve opens, it sucks it in and it fogs the fuel. It literally fogs the fuel. So try not to imagine it shooting in the intake valve and it's filling up with fuel. It does not have time to fill up with any fuel. It's a solid fog the whole time. And it helps atomize the fuel because they're called air bleed nozzles. They bleed air to help atomize the fuel. Now, to complete a fuel injection system, you need an engine-driven fuel pump, the boost pump, and the fuel lines. Of course, the boost pump is for 2 reasons, for engine starts, to prime your system, and for emergencies. Everybody's seen one of these, right? This is an engine. The flow divider basically goes on top of an engine. It's just there for convenience. It can go really wherever you want. The fuel line lengths do not matter. You can have a 3-foot fuel line. You could have a 5-foot fuel line. It doesn't matter. The line length does not have any effect. Of course, the nozzles go into where the primer ports are, and then the servo is usually mounted down here, sometimes vertically, a lot of times horizontally. It just depends. But the servo doesn't care because it's not storing any fuel, so it doesn't care how it's mounted. We recommend TVO, both carburetors and fuel injection. To TVO the engine are 12 years calendar time, and this is due to what the engine manufacturers say. We're only fuel control people. We're not engine people, so we really we agree with what the engine manufacturers tell us, and we go with what they say. Like I said, we're not the engine authorities. So we're not, we have a lot of opinions about engines, but we're not the engine authority. Again, the reason for the TBO, the 12 years, is because of fuel control sitting, and this is mostly carburetors where the fuel starts breaking down. It forms acids. Acids cause corrosion, and then you get varnishing, and everything gets clogged up, and everything becomes brittle. All your gaskets and your O-rings and things kind of just go downhill. So you don't really want to let it sit if you can possibly help it. And also your fuel control usually is the lowest component of your fuel system, and that's where all the moisture goes. So that's why you also want to drain your bowl probably every year, just to drain the contaminants out. This is a cutaway of the servo. We're going to start learning about the diaphragms here in a sec. Your fuel inlet's right here. It comes in. This is the filter. It gets filtered and it goes down this port here, and it comes in here and fills this whole area up. This is your mixture lever, and it's connected to the shaft, and the shaft goes in here, and on the end of that shaft, there's a plate. This plate rides on this valve. So you got a plate that goes back and forth on this valve, and this valve has a big hole in it. When you're at idle cutoff, the plate sets the hole. As you go to full rich, you open the hole and you allow the full amount of fuel to go through this, we call the mixture valve. And then it goes through another valve, which is called the main metering jet. And again, you got another plate riding on a valve, and it's metal on metal. That's why even brand new servos are allowed to leak. Every fuel injection servo that's built is allowed to leak up to 5 cc's a minute static leak. They're allowed to because these are not seals. When we manufacture these, we try to get them as flat as possible. We measure the flatness with light waves. So it's a 0.5 zeros and a 2 of flatness is what we want of this valve and this plate. They're very shiny mirrored finish when we put them together, so they seal. Most of the time they work great. They shut off the engine, but did you know that these are not made to be shut off valves? That's why you have the shut off valve in your airplane, is to shut the fuel off. These are sufficient enough to shut the engine off, but they've been used for years as a shut off valve, but they weren't designed that way. And it's good to understand that these can actually leak, even brand new units out of the shop, because these are not seals. It's metal on metal. This plate here on the main metering jet is connected to this shaft, and this shaft is connected to the clevis assembly, and you got your thumb wheel, and this is where you adjust your idle mixture. When you turn this thumb wheel, you're turning this plate, opening or shutting a hole to get your 25 to 50 RPM rise. There is a letter R on this clevis to turn the wheel to go richer. And then of course you go opposite, you go leaner. So you want to see that 25 to 50 RPM rise, and all you're doing when you're turning that thumb wheel is envision inside this little plate just going like this, opening and shutting over this hole to get that rise. Once this opens at 12 to 1500 RPM, it doesn't matter, because your diaphragms are metering the fuel above 12 to 1500 RPM. This is also called the idle circuit. This works up to 12 to 1500 RPM. After that, after this hole is open, the diaphragms are metering all the fuel. Here's the mixture. Here's where your mixture lever goes, is on here, but here's a stop. It says ICO. This plate is over the valve. It's over the hole's shut. It's at idle cutoff. If you open it up, it turns this plate and opens the hole. And here's the plate open. Here's the hole that's open. And you can see ICO is idle cutoff. And then there's an R for rich, and it hits this stop at R. That just means the hole is wide open. So as you go up in altitude, you just start shutting the hole off. When you come down and you go to idle cutoff, you just shut this hole off and you get idle cutoff. Very simple how it works. Now we're going to talk about the diaphragms real quick. Your fuel inlet, your fuel comes in here, gets filtered. It comes down. Now there's a fuel diaphragm. There's two parameters, two forces on this fuel diaphragm. Unmetered fuel will bypass all this stuff. It goes through here and comes up and it goes to the unmetered side of the fuel diaphragm. Then you have metered fuel, which is fuel that goes through the mixture valve. Here's that hole, and then here's the plate. But it goes through that mixture valve, and then it goes through the main metering jet. Once it comes out of this metered hole, it becomes metered fuel pressure. It goes to the opposing side of that fuel diaphragm, and those are opposing each other. Now we got to talk about the air diaphragm. There's two parameters on the air. There's impact air. If you guys look at your RSA 5s on the bottom, you're going to see 4 little tubes sticking out of the throat. That's impact air. That's where your air enters in these little tubes, comes in, comes to the impact air side of the air diaphragm. The air diaphragm is right here in the center, this line. And then you have the suction of the venturi coming down to the other side of that air diaphragm. As I stated earlier, both diaphragms are hooked up by one rod, and on the end of the rod is a steel ball that sits in a seat. As you operate your throttle, your butterfly, you open it. As you open it, it changes all these parameters and it lifts that ball off the seat and meters fuel. And it does it very accurately. That ball only lifts off the seat about 40 thousandths of an inch total from idle to full power. So it's pretty amazing how it works. Here's a cutaway of it. The red right here is the fuel diaphragm. The blue right here is the air diaphragm. Here's the shaft. They're both connected on the shaft, and there's a steel ball that sits in a seat inside there. The way we flow test these is we put the fuel diaphragm on, and we use different strengths of springs at different throttle settings to get the flow that Lycoming requires for that spec, that flow spec. Once we get it all flowed all the way up to throttle range, we add the air diaphragm to it, and we have there's little lock nuts on here that we put on the airbox flow bench, and we actually adjust those little nuts and adjust the air in. There has to be so many pounds of fuel, so many pounds of air at a given throttle setting. And we go all the way up through the range of the throttle to set those together so it'll run properly. This servo goes on 160 or 150 horse all the way up to 260 horsepower. It does not care what's good. We can put 50 gallons an hour through these things, but we can only flow test them to what the parts list number is, because it has a specific flow spec that it goes by, and it's got to have a specific fuel flow. Flow dividers, we basically manufacture a flow divider. Lycoming gets them with plugs. We don't do any of these fittings. They're all done by Lycoming. We get them with plugs. They got a 4-cylinder engines. They got 6-cylinder engines, and you can put plugs into 2 ports that you don't want. This has 6 ports for a 6-cylinder. So if you got a 4-cylinder, you just plug up the 2 ports you don't want and put your fittings in. They got straight fittings, 90-degree fittings, 45-degree fittings. So there's 35 different part numbers of flow divider when it's actually the same flow divider. It's just how it's configured. And the way the flow divider works is after the fuel is metered by the servo, it comes up underneath this. There's a piston in here, and the fuel pressure pushes the piston up. And this is a 2 PSI spring. So this opens at 2 PSI. When you're at cruise, your flow out of your flow divider doesn't go much about 7 PSI. That's it. That's all you got flowing, but that's plenty of flow for the engine. So anyways, the pressure pushes the piston up. It opens all these ports equally out to each fuel line. And then when you go to idle cutoff, the spring pushes that piston down, shuts off all the ports equally, so you don't have dieseling and siphoning back and forth of different cylinders. So the flow divider's job is to divide the fuel evenly and give you a clean idle cutoff. And that's how it does with that spring. It gives you a clean idle cutoff. So the servo meters fuel. flow divider divides the fuel. And now we're going to go to the next thing, the air bleed nozzles. Again, the air bleed nozzles bleed air to atomize the fuel. It's got a brass body, it's got a screen, and it's got a steel shroud over that screen to protect the screen. Underneath that screen is a little bleed hole drilled into the side of the body of that nozzle. This is the jet. This is called a restrictor, and the jet size is 28 thousandths big. It's all our nozzles are 28 thousandths. That's the size of the hole. This restrictor fits inside this body, and you can see where this little step is right here. That's where the bleed hole is drilled into the body. So bleed air comes in under that screen, bleeds into the nozzle, and goes in with the fuel and helps atomize the fuel. So again, you want to use proper torque. These are brass. The max torque into the cylinder is 60 inch-pounds, and the max torque for the fuel line is 50 inch-pounds. There's a letter A, and it used to be very important to have the A up because the bleed hole in the body is 180 degrees of that letter A. So when you see that A, 180 degrees is where the bleed hole is drilled. And they always wanted it up slightly because when you shut down, you have residual fuel that might come out of the nozzle, and you don't want it leaking on your engines. But it's much more important to get the torque than it is the position of the A. So as long as the A is 90 degrees or 180 degrees, so it doesn't just flow out of the nozzle, if for some reason you some fuel will come out, you're okay. But torque is much more important. We recommend Hoppy's number 9 gun cleaning solvent for cleaning these. You soak them for 20 minutes. You got to keep these together. These are match set. You can put the assembly in any cylinder you want, but just keep these two things together. When we match them up at the factory, we randomly put a restrictor in, and what we want to see is a very fine line of fuel coming out of there. We do not want to see any kind of spray coming off that nozzle because that means it's not going to flow properly. Once we get that fine line of fuel, then it has to flow so many pounds of fuel an hour. It's like 28 pounds up to 32 pounds an hour. So there's a variance in flow. Proper torque, like I already talked about that. Dirty nozzles cause a problem. You can tell pretty much if you have a dirty nozzle. Sometimes when you're pre-flighting, if you see blue fuel dye on the shroud, that's a good sign that maybe your nozzle's dirty. And what's happening is the nozzle's dirty inside, so it's forcing fuel out of the bleed hole and it's getting out on your shroud. It could also be because these threads aren't clean and you don't have the proper torque. So you got to check those too. If you have one dirty nozzle in a 4-cylinder engine, what's going to happen is that dirty nozzle cylinder is going to run lean and rough. And then it's going to split up with the other 3 cylinders, the fuel that it doesn't use because it's dirty and it's running lean. So it's not using the full amount of fuel it's supposed to. So it divides it evenly to the other 3 cylinders. So you have 1 lean, rough running cylinder, and you'll have 3 slightly rich running cylinders. So it's important to keep them clean. It's very simple to clean them. If you're flying a lot, you can just take the restrictor out and clean it and put it back. But we do recommend you take the whole nozzle out and you soak them and you clean them. We also have videos on our website, precisionairmotive.com. We have all the videos on how to clean your inlet filter, how to clean your nozzles, how to troubleshoot it on the airplane. If you don't get a clean out, it'll cut off, what to look for. If you're running rough at idle, what to look for. And that's all on our website. It's pretty informative. So if you go on our website, go to technical and then videos, you'll find them. Just like the carburetors, we have a troubleshooting chart. Again, to me, a good mechanic is a good troubleshooter. If you know how to troubleshoot effectively, I think it makes you a better mechanic than just swapping things out and taking things off. These have gotten very expensive over the last 26 years. And it used to be when I got hired, the guy'd call and go, hey, this isn't running good. Oh, I'll send you another one. Oh, hey, this one's not running good either. Oh, hey, I'll send you another one. Hey, no, you got to get those other 2 back to me. So we don't do that anymore. these fuel controls, your fuel control are $1,500 right now for an exchange overhauled fuel control of your size for your 320. The flow dividers are about $250 and nozzles are about $80 a piece. So nothing's cheap anymore. We have a series of manuals that you can also get on our website under technical data. This is the first, it's a training manual. It just covers the servo flow divider nozzles, the basic operation of it. We make them short, so they're easy reading, and you could probably read this in probably a half hour or less. And it's got big print and it's got lots of pictures, just what the guys want. You get more into depth with troubleshooting techniques. Again, it's another big, it's only like 15 pages, but it goes through some good stuff. How to do a flow test on your nozzles, how to readjust your idle mixture linkage. It goes through different things. So it's good. It's also on our website. And then we go through the most in-depth manual we have. It's called an ops and service manual, but this gets the most in-depth with troubleshooting before you need to take the system off and have it flow checked. And again, we'll flow test your system for free. If you think you've got a problem, we'd like you to call us and we'll help you try to troubleshoot it and figure out what's going on. But these manuals, unfortunately, with fuel injection, you can't field overhaul them. All you can do out in the field is change external things like clevises and that type of thing, fittings or whatever, but you can't overhaul them because you need a flow bench to set up the fuel diaphragm and the air diaphragm together. I've had like 4 or 5 guys try to overhaul them. They call up and they get our overhaul manual and they get the overhaul kit. And I said, well, save another $500. And they go, why? I said, because when you get it back together, it's not going to work right somewhere. It's not going to run great. And because what they do is they take the air diaphragm, they go, okay, I got a nut on here. Let's see, 1, 2, 3, 4, 5, 6. Okay, 15 turns. Okay, the other nut comes off with 40 turns. Okay, the new one, 40 turns, 15 turns, and then it don't work. So one part of the range will be good and the rest won't be good at all. So you need a flow bench to calibrate. This is an active CD-ROM. We used to have these CD-ROMs, but we just put all the videos on our website. I mean, each video is a 2-minute video, and we have 6 of them, and they're very educational. They'll show you a lot. Now, there's only 2 adjustments you can make on our fuel injection, and that's idle speed and idle mixture. When you're adjusting your idle mixture, again, you're turning the thumb wheel, and down here on the end of that shaft inside, remember that little plate is sitting on that valve and going off and on a hole. And that's how you're adjusting your RPM rise at idle cutoff. You always want to adjust your idle mixture first, and then you'll be able to do your idle speed. Again, if you can't get below a certain RPM with your idle, it's pretty much guaranteed you got an intake leak. So if you get down to 1,000 and you can't go any lower, you probably got an intake leak. We're pretty confident that we can tell people, yeah, you got an intake leak. You got to figure out what's going on. So little maintenance. This is your inlet filter. Again, the videos on our website show you how to clean this and take it out and everything, but we always recommend you replace the little O-rings. This O-ring goes right here on the filter. And then this filter sticks in here and that little O-ring seals that up. And then this O-ring goes on the fitting. So when you put it in, it forces the fuel to go through and get filtered to this filter. This is a 70 micron filter. And they put a spring on it. It's also called a bypass filter. And the reason for the spring is in the event that you get your filter fully plugged up with debris or contamination, fuel pressure will actually push the whole inlet filter in and allow fuel to get by to keep running. But if your filter is fully full, I don't see how long you're going to be running because you've really contaminated it. But that's the purpose of that bypass spring. Apparently it happened prior to 1988 when we bought the line, because this was already in service when we bought the line 33 years ago. So it happened somewhere. It used to be, the fitting used to be soldered on the end, so it's soldered right to it. And they went to that bypass type. We, I don't say we hire mechanics, we hire assemblers. We get all our parts manufactured locally in the US, and we get them all in, inspect them, and then we have people build up 10 or 20 at a time, and then they get put on this airbox flow bench. And this airbox flow bench, we're able to test the operation of the venturi, and we can more finely adjust the servo. Once the servo goes out into service, when it gets overhauled, that venturi shouldn't have to be checked. So we make sure everything's working properly before they leave. One mechanic or one assembler builds 10 or 15 or 20 and then get them on a flow bench. And then if we find any problems with them, we can trace it back to who built them and we know exactly who to fire. Thank you very much. Before the 2008, we had, when we had our big turn down, we were doing about 1,200 fuel controls a month. And that's including Marvel Sheblers, the Bendix pressure carbs, RSA fuel injection. But now we're doing about roughly 600 carburetors a month, which is still a lot, and about 300 servos a month, 300 fuel injection servos a month. So it's still doing pretty well, but we used to do a lot more back in the good old days. So any questions, you can call us at any time, go to our website. There's a lot of good information. If you want to see some stuff, or you can call me and I'll walk you through the website. I'm really a user-friendly kind of guy. And I'm more than welcome to invite you people to call us up, and we want you to keep flying, because if you're not flying, you're not wearing out your systems. We want you to wear out your systems so you can buy replacement ones. So is there any questions?
Al, I just wanted to say thank you.
Oh, you're welcome.
Years back, I had some issues with mine, and it turned out everything you said was right on the money. And my problem was on the some of the fuel pumps are the vane type pump, the Lear Romec pump, and it has a diaphragm, and the diaphragm, even though it was brand new, was leaking, and that screwed up everything, because fuel would come back down and through the vent, and you get drawn in that way. So it messed up. But I just want to thank you. You were very patient with me, and I learned a tremendous amount from all of your publications and everything else.
No, I got a dartboard here that it's full of darts. I was not patient with you at all.
You remember me?
No, I'm glad. I mean, we want to help people. That's what it sounds really weird, but we actually want to help people. By the way, I'll be at Oshkosh. If you guys want to come in and to our booth, we're in the C building right behind it. We're on the other side of the wall from the toilets. Easy to find.
I'm coming to shake your hand and say thank you. I'll be there.
Okay, well, we'll have cold water and other beverages and snacks too.
And beer. Yeah.
Well, yeah, we have that too. That's on special request. But what I like to do, especially with the older guys, when I see them walking through and it's hotter than hell out, and they're sweating and they look like they're beat down, I sit them in a chair, I put the fan on them, and I go grab a nice cold water, open it for them, wipe it off with a towel, and I hand it to them. I said, "You need to cool down, sir." And they're really appreciative to that. So yeah, if you're at come to Oshkosh, I'll be there. It'll be my 24th in a year in a row. So except last year I didn't go, but yeah, it's fun. I like doing it.
Yeah.
Awesome.
Yes, sir.
There's been a little bit of controversy about fuel flow settings for twin Comanches, and some folks have said that when they talk to folks at Precision, they're told that they can't get the 16 gallon an hour flow. It just isn't correct. It's never been correct. It's just internet hogwash. While other people have said they've successfully negotiated their way through that, and gotten their servos back set the way the POH requires. And now if you're here, I feel like you're the horse's mouth, and I'd just like to hear from you.
Yeah, it's funny you brought that up. Is Kurt, are you on this thing tonight? Kurt is a guy that we just helped with his twin Comanche. I've had several phone calls in the last
Kurt
2
is
months.
here.
Kurt's here.
Yes.
So we helped Kurt, right, Kurt?
You did. You were a big help.
Okay, so Kurt called me up and said, hey, I need to get whatever he said, 19, I don't know what he said.
Probably 16, which is what the POH says.
Right, 16 gallons, and he wasn't getting enough. And I said, well, when I look at our flow sheet, remember I said we can only flow to the parts list of the servo. And so what happened is when we got Kurt's servo in, it was basically, there's a range of flow. There's a lean limit and a rich limit. All we did is take his servo and put it to the rich limit, and it solves a problem. So my question is to all you guys with your servos, you should let us flow test them and see where they are.
Well, here's why I asked you the question, because many people have related what you just said is coming from Precision. But there are also people on the list that have been air racing their Comanches for 30 years, sponsored by Lycoming. And they've said that when they in particular call you and give you the POH, they don't get the generic parts list number right around, they just get it back set correctly per POH. And I'm at a place where I might just be prophylactically replacing my servos because there's a little bit of variation in cruise and they're more than 12 years old and the airplane sat for a bit before I got it.
Yeah,
but I don't want to, I live in Minnesota, and in February, I've got 30 inches of manifold pressure because it's cold.
Yeah.
And I'm flowing probably, depending on the day, over, right at 16. And I don't want to risk getting it back because somebody's giving me a parts number set up.
Well, you know what I'd really like to do? I'd like to talk to some of these guys that say they sent their servos out and got them fixed and they're happy, because I'd love to flow those to see where they really are.
Right.
We don't know where they really are. And like I said, we have a lean and a rich limit, and we never put them to the rich limit because we don't want people having rich problems, right? So we kind of put them in the middle. And like I said, after Kurt's servo went out and he's okay with it now, I'm thinking, well, you know what? The Comanche guys really need to have their servos set to the rich limit. And it might be as simple as that. Now, what I said earlier too is Lycoming gave us the flow spec. We have their flow spec, and that's what we flow to. So per that parts list number, if you send it out to any other shop and you say, give me 16 gallons an hour, they'll give you 16 gallons an hour and they'll probably be out of spec, which is what we worry about. So it's a fine line of, how much fuel you guys want and how much we can actually give you. I think
it's not what we want, it's what the type certificate holder specifies. It's what the type certificate.
What's kind of weird to me is, why doesn't Lycoming change the spec for us? It's their flow spec. It's not ours.
Right.
They dictate to us what we flow at. And like I said, they're the type certificate to all the flows of all the engines, and we cannot go outside of their parameters of what they tell us we can flow. So I'm thinking seeing a couple servos would really be helpful for me to see where they really are.
Well, that's
so Alan, let me just add one thing in, because it's relevant to what you're asking. A couple of people have pointed out that 16 is red line. And so Dad noted 16 gallons per hour is the red line. The POH doesn't specify 16 as the desired flow value. It shows the red line.
That's not true. It's a green. It's part of the green. So.
Okay. So is that true for everybody? Because the reason I'm asking is because I'm not sure I don't fly a twin. Did the POH change at all from model year to model year? Some are saying it's the red line. Alan, for you, it's regular green, right?
For me, it's.
Or John, sorry.
It's
John,
the end of
you're-
the green. It's the green range includes 16. It's
right. So
somewhat
can other
misleading
people
to say
jump
it's
in
the
and
red line.
just confirm that their POHs are showing red line? Because I'm wondering if this is an opportunity to go back and ask for a clarification from Lycoming or something.
Well, it wouldn't come from Lycoming. The engine installation is certified by Piper.
Right.
Oh, good luck to us getting a Piper.
Yeah.
So Dad, the person who's identified as Dad, you had mentioned your POH is showing it as red line, and Kurt, yours.
That's what I'm
You'll need
led
to
to believe, and that's what the gauge says. When I talked to Lycoming, they said 13.5 to 15.2 was the range that is in their operator's manual for an IO 320. You know, I don't have any definitive answer on, is 16 the desired number? Is that the red line? If you know, it's the top of the green, sure, but does that mean that's what you have to have?
Yes.
The top of the green also includes an oil pressure. Do you have to have that top of the green oil pressure? No, you don't. So I don't know what the correct answer is.
I have the original POH plus but I fly with the twin Comanche, the published one that we have now, and they both list the green range terminating at 16. And it's not Lycoming that sets the engine installation, it's Piper.
Yep.
Yeah, Piper tells Lycoming what they want.
Right.
You know, there are a few cases where the kilo manual and the POH have small disagreements, in which case the original Piper POH can dominate. And in that case, as Kristen Winter has advised, she's one of the people affected. And she said, I have written on my POH something like advisory only, and then she carries both and the Piper POH dominates.
Right.
I'm wondering if this is a situation where the kilo POH may have one of those small errors. Zach Grant actually is intending to try to go ahead. He's been keeping a list of the changes that we need to make. This is a little random, but one of them is for those of you with 2-tank Comanches, your tanks actually do each have 30 gallons usable, but they're in the kilo manual, they're listed as being 28, with 2 gallons per tank unusable. That's actually not correct for the 2-tank Comanches.
Can I interject something?
Yeah, please.
I want to make sure that everybody understands we're using calibrating fluid when we're flow tested.
Right.
We're not using gas. So I personally don't know for a fact what the properties of calibrating fluid are to gas. I don't know if calibrating fluid's thicker than gas, so it's going to flow differently. So when you get it, you'll see more, but we do it with our calibrating fluid. So if somebody's smart out there about chemicals and calibrating fluid and gasoline, maybe there's a little, there's a shrinkage thing in there or something that's, I'm telling you one thing, but maybe it's not, because that's in calibrating fluid. It's not in gasoline.
Chris Barber, let me throw out a little bit of direct experience on that. The U.S. Army had changed from JP4 to JP8. JP4 is half gasoline, half kerosene. JP8 is all kerosene. And what they found is that the fuel controls on the JP8 aircraft were starting to have some issues. They'd take them to the depot, and the depot would bench test it with cal fluid. It worked just fine. They send it back out. They run it on JP8, and it would have issues again. We're working with the fuel control manufacturer, and I got them to run it on JP8, and they did finally find the issue with that. But I doubt that. There's such a difference between kerosene and avgas that it would be applicable. Let me ask my question that I've had before we get off the 16 gallons. Several Zooms ago, a gentleman was discussing aerodynamic improvements, and he put some bell mouth inlets such that the air flowing into his engine fuel injector system was probably doing a whole lot better than the stock system, because he says that he was seeing more than 16 gallons per hour at full power when you guys calibrate them at 16 gallons. Do you guys calibrate them at a certain airflow amount?
Yes.
And then Okay, so
Here, let me tell you, I got it right here.
so when you say 16 gallons, it's 16 gallons at a certain airflow, you know, which corrected to all that.
Yes.
So when he sees more, that the reason he's seeing more is because he may be getting more airflow than the calibration airflow that Piper has determined that you will use.
Yeah, that sounds reasonable to me.
Okay, thanks.
Here, let me, okay.
And while you're fumbling, here's why I'm asking this big question. I may rebuild my motor in on my little 320, which is a 7-1 compression. I put the Lycoming cylinder with the valve jobs in, and I think I'm getting as much power as the people that have to use the expensive gas. And I'm looking to put those cylinders on my little carbureted 250. If they flow more, will the carburetor still be okay with that?
You're talking about a carburetor?
Yes. The 250 is a carbureted aircraft, but I can slip these cylinders that they say will flow better, and I can put it on a 260's dual exhaust, and I'm wondering, will my little carburetor still be happy? If I could get more airflow through the engine?
I can give you a personal experience on that. I built an RV7 with a 320 off a twin Comanche that I converted to a carb with Lycoming cylinders, and the carb had enough range to just meter and give me the appropriate idle rise and, you know, EGTs throughout. Ran cool. And it seemed to me, my RV7 at the time ran with the 360 horsepower performance numbers that Van specifies. So I think this was 12 years ago. I think Lycoming is actually not selling snake oil. I think it actually is pretty darn good stuff.
Well, like I said,
South Africa, and they crashed it. So
with lawnmower gas in my 150 horse engine, I'm pulling the same propeller pitch and diameter as the 100 low lead octane 160 horse engine, and very happy doing it that way. And I would do it to my Comanche in a heartbeat if I thought we could get away with running auto gas in that low wing.
All right, here's our flow sheet for that. Where's the air? I gotta find the air now. Where are you, air? Yeah, and I don't, you know what? I'm not gonna be able to tell you what this means. At full power or at the top end, it's 1,400 pounds of air. I don't know what that means. So it's 1,400 to the full flow. And then we have 4 different settings. One's at 600 airflow, and one's at 0, one's at 300, 600, 1,400. So, you know what? I'm going to investigate this a little bit and see if I can find out anything about, I don't know if it's even the right word, viscosity of calibrating fluid to fuel is. Because I really think that that might be one of the problems that we're having is I'm trying to tell you that we're flowing you, you know, we can only flow you 14 gallons, but you're saying you want 16. Maybe you're getting closer than I think.
What's funny when you said that is I did a little quick math.
Yeah.
And a ratio of 13.7 to 1 at 1,400 pounds of air is about 102 pounds of fuel, or about 17 gallons.
Oh.
So, and I just picked 13.7 because at least in the air-cooled Porsche world, that's what we like to see at high output. Because
yeah, so maybe it's a combination of the calibration fluid to the fuel to the gauge, whatever the gauge is reading. I mean, is it, you know, how accurate is that? You know what my question is? My question is, how's your engine running? Let's talk about that a little bit.
I don't want to give up any fuel flow. I just don't.
Yeah, but do it
pretty good, and it shows 16.1-ish on takeoff.
Have you done any lean out rise tests throughout the throttle ratings, like at full power?
Yeah, it has gammies from the previous owner, and so when I first bought it, I went up and did all the tests, and it's yeah.
Well, if you can lean, you know, 100 degrees to 175 degrees,
yeah,
reach a peak, you're doing fine.
Right. I just don't want to lose any of that if I send the servos in.
Well, you won't lose it. I mean, we're not gonna do anything to it if We can just flow test it and say, here's where it's at.
Right. I'll let go of this though. I feel like too much time.
No,
You
it's
know
okay.
what, Chris, your questions are those of a lot of us. This is
Yeah.
a helpful discussion to many.
Unfortunately, too, there's a lot of variables. to
John, sorry.
everything. A lot of variables to everything we're talking about. So it's not just a cut and dry thing. It's it's everything. It's the engine application. It's all kinds of things that determine the fuel flow and how it flows and how it runs. But I guess our biggest thing is, how's it run? You do lean out rises, you get in 100 to 175 degrees, reach a peak, you're okay.
But
You're
but
not burning, not
if-
burning
if-
your. Go ahead.
you only flow them to so much, and you get so much fuel flow. And if Hans is getting more fuel flow, that curve, I guess, means that he is also getting that more airflow. Isn't that correct?
Yeah, you can't force any more fuel through it with air, because the servo is a fuel regulator. It's regulating the pressure that's coming in. And I actually need our engineer to explain it, not me. It's you can't force any more fuel through the servo. And
Can
if
you do
you
it with
want
a
more
carburetor?
fuel, pardon?
Will the carburetor, if you get more airflow through the carburetor, will it give you the fuel flow ratio correctly?
See, I'll ask the engineer that too, but it doesn't make sense to me. By forcing more air, you need more fuel, but if you want more power, you need, I don't know. I'm not versed for this.
You know what we might be able to do that would be interesting, everybody? And the reason I bring this up is, if anybody caught Hans so we have a DER, Alan, named Hans Newbert, who has a twin Comanche, and he's an efficiency freak. And he designed some things to improve. If I recall, he created these smooth rings that go on some part of his intake system. Those of you who saw it probably understood this better than I did.
Built-in bell mouths.
Yes. Yes, exactly. And I think they increased ram air pressure, and they allowed him to get slightly better, like 15% better power, which is the legal limit. You're allowed to do some tweaking with your engines, and then beyond a certain point, that's not legal anymore. And let's see, we recorded his prezo at ComancheTown at Sun and Fun, but we had a problem with sound that we're trying to sort out. And then he also gave it a version of it on the Comanche Zoom after Sun and Fun. So it's a recent one. Did he talk about, and I had to miss it, I was sick that day. Did he talk about those bell thingies, whatever you called them, Chris?
Yes, and his proof of the pudding was that his 16 gallon per hour limit servos are showing more gallons per hour when he firewalls it and goes to take off. And so I'm asking, does that mean he's getting more airflow? Because that's what those bell mouths are all about.
So, and Alan, I just want to mention that and everybody else that's here probably will be interested in this. So as you all know, our airplanes aren't made anymore. We are going to be needing parts. And also we have some really fantastic innovation coming out of the Comanche community, because we've got a bunch of mechanics and other, mechanical engineers, ANPIAs that own Comanches that are interested in tweaking. So so what happened is that Matt Kirk did this amazing remote consult. He's one of our gurus of landing gear maintenance and improvements. And in fact, Kirk even has a small speed mod, which everybody seal up the gaps in your wheel wells. Your airplane will go marginally faster, like almost a knot, because your air is not going to flow into your wing and create turbulence, and something that Matt said that's magical that I'm doubtless saying wrong. We could arrange a discussion between Hans Newbert and you and your technical guys. And if there's innovation there, we now have people who are coming into the consult program, which hasn't been announced yet, but there's 3 DERs, guys with a bunch of STCs and like 80 field approvals and PMA approvals. If we come up with great innovations, we're happy to help bring the resources together to make sure they become available to the community. That could help if they fall under precision airmotives area, we're cool. We just want better, faster airplanes that fly more efficiently and safely. So,
Right.
you know, we'll
Just
help
keep-
innovation.
Just keep in mind, Lycoming owns the type certificate to the field control, so we can't just go changing things off.
No, but
So
Newbert's a DER and he's kind of careful about the regs. So he was dancing around how to get more performance while following the rules.
Mhm.
So
Yeah,
anyways,
that all sounds
just
good.
an
I
offer.
mean, yeah, we're gonna have to do things about, you know, the ailing aircraft and parts and all that.
Yeah,
Well,
and
So
it's
like, we
crazy,
wanna
but
see it.
I mean,
Don't we
Garmin said that they changed their process for approving the Garmin just approved the GFC 500 for all of the Comanche singles after Zach Grant passed a list of aircraft over to Garmin during one of these Comanche Zooms. We ended up with a flight test of what's the best speed to drop your gear that never existed before on one of these. So it's like, you know, you want us to do stuff, we'll bring you the resources.
I'd like to see Hans's servo. I'd love to put it on a flow bench if he says he's getting more fuel.
Okay.
I'd like to see that's happening.
Well, if it's calibrated properly, that means he is getting more airflow.
Let's see
And-
what, yeah, we'll know exactly. As soon as we put it on the flow bench, we'll know what he's getting.
And I'm coming back to my question. So I've got my little carbureted 250. Lycon will sell me the cylinders that I believe in my heart that they do flow more. And I think that dual exhaust isn't going to hurt me, you know, compared to the one I got draped across the firewall. So that little carburetor, you put more air through it, it will meter properly.
Well, you got to remember the main nozzle of the carburetor is flowed to a specific flow. So it might take it and make it better, or it might start making it leaner because you don't have the fuel flow out of that nozzle.
So there's a main jet restriction on that nozzle.
Yeah. Yeah, it's got a jet that we ream out and we flow to what the carburetor is. So if you're going beyond that, it may take the fuel that, you know, if it's between rich and lean, it may take the fuel enough to make it turn it down to lean. I'm not sure. That's another good engineering question.
Hey, and oh, by the way, my 320's carburetor sat for about 3-4 years with auto gas, and you'll be seeing it. And thank you very much for that free service.
So I have go ahead. I'm gonna just bring forward a question. There's 6 or 7 questions queued up, but everybody just agreed. There's a question that a lot of people have, I know, and it has to do with starting engines with vapor lock. So Serge, do you want to unmute and just ask your question, or do you want me to go ahead and read it? I'm just gonna read it in. What's the proper technique to get rid of vapor lock and start the engines? And the other question is, you had mentioned that vapor lock can happen for, let me just go back and you had mentioned we do a Comanche Zoom test flight ahead of time. You had mentioned that hot starting varies depending on things like, you know, what exhaust is fitted to the engine. So go over to you.
Well, hot starts is pretty simple. The fuel boils out of the lines when you shut down a hot engine. So you end up not having any more fuel in the lines. You got vapor. The trick is trying to get the proper amount of fuel back in the lines so your engine will start. A lot of people, and of course they have to have it on top of the engine. So that's the first thing that happens is you boil all the fuel out. So it's the technique of hot starting. Now I can line 10 guys up and they'll have 10 different ways of hot starting. But the most common way is idle cut off, mixture cracked, and turn the key. When it starts to fire, slowly feed the mixture in and your engine will keep running. Now that's the most common, but there's probably 10 other different ways. Some guys will go, I idle cut off, crack the throttle, I hit the boost pump, for 3 seconds off, then I crank it. No, I do it full throttle, full mixture, hit the boost pump, see 3 to 5 pounds. Then I cut everything off, crack the throttle and start. No, I do full throttle and start cranking. I mean, there's all different kinds of ways, but the whole thing is when you find the way that works, that's the way that's probably going to work every time. So hot starts is a crazy thing. It's all about trying to get fuel in the lines to start your engine. That's what it all boils down to. Excuse the pun. Vapor lock. What causes vapor lock? Heat. What does heat do to the fuel? It makes it bubble. You guys have heard of cavitation, right? Cavitation, like on a boat. You put the prop in and it starts to cavitate because it starts eating the air and it's not grabbing any water. Well, that's what vapor lock is you're literally got bubbles that are trying to pump through the pump and it won't because it can't grab any fuel. There's too much air in there because it's hot. So the solution, park in the wind, open your cowl flaps, try to cool it down as best as you can, because we also learned when Piper called us every summer and said, hey, your servos aren't working again, and it's the middle of summer, we went to Vero Beach and we learned that it's 180 degrees under the cowl of a Piper. And we learned also that fuel starts to vaporize at about 130 degrees. So at 130 degrees, the fuel starts to vapor. And the fuel was actually vaporing from the servo up to the flow divider. It was actually vaporizing in that number six fuel line. So what we did is we put a bigger spring in the flow divider to help force more fuel up and force more fuel out the fuel lines to try to help alleviate that heat problem. But unfortunately, Pipers are very tightly cowled and much more than a Cessna 172. And so they have a much more heat soak problem, and they have much more vapor problems and vapor lock problems, but it's all heat related. And what are you going to do about it, right? I mean, the only thing to do about it is to cool the fuel down. So there's no answer as how do you start a vapor lock fuel pumped engine. Got to get the vapor out of there.
So there is one thing that helps some people, which is when you park your airplane, most Comanche singles have the oil filler door on the top of the cowling. Yep. And in addition to parking your Comanche pointing towards the wind, if there is any, try popping open that fuel filler, that oil door. And it tends to be able to release the heat from under your cowling. More, because you now have a thing on the top for the hot air to go out. And that's a Zach Grant special tip.
And it may help you also a little bit to put fire sleeving on all the fuel lines, not just have straight stainless steel fuel lines on top. Put some fire sleeving on them to try to help alleviate. And fire sleeving, of course, it's already on the line that comes up to the flow divider most of the time, because it goes between the cylinders a lot of the time. So anything to help keep it cool. When you start your engine in hot weather, don't sit on the ground for a long time and heat it up. Go fly. So, and when you land, don't just keep taxiing around. Try to get where you're going and shut your engine down so it has a chance to get rid of that heat.
Yep. And a couple of other comments on that. Chris, so Mike Ellis points out, he also pulls out the oil dipstick and vents the crankcase. And Zach Grant has also recommended that as a way of getting the vapor out of the oil. And Mike, are you saying it'll also cool down things as well?
No, I was just saying, hell, while you got it opened up, pull that out so the water vapor comes up out of the oil pan. That's all.
Oh yeah. And that, everybody's a great tip, because getting the water vapor out of your oil is going to reduce the chance that you're going to have corrosion in your engine from the oil in your, from the water vapor in your oil, in your cylinders.
I doubt that when you land, there's any water vapor left in your oil. It's an open vented crankcase in an engine that's running at oil temperature of 180 degrees.
Yeah.
You
That
get
sounds-
water vapor when the metal cools and gathers water out of the atmosphere in a situation where the metal cools below the dew point.
I
But
see what looks to be steam coming out of the oil dipstick thing.
I just,
So I
yeah, I mean,
don't know if it's steam or not.
I went into, when my dad was alive, I went 3 rounds with him on this because I read the same aviation article that gave the same tip. And he's like, all you're doing is leaving your engine oil open to something falling into your dipstick tube. So I'm kind of repeating an ass whooping I got on the topic, but he was a, commercial rotorcraft multi-engine and turbine rated helicopter guy, our crazy Army helicopter guy. And so take it for what it is. He was always a stickler about that.
Can't you shut down and then take your prop off and turn it around and start your engine again and have your air go the other way?
If you had beta.
DJ,
Ahead, Hank.
yeah, something else I do, because it gets kind of hot here in the summertime, is I have one of these handy dandy
clips,
big paper clip with a handkerchief or a synthetic sponge to keep it from scratching up the paint job. Put both halves up, clip this on the top. Then you got a great big huge area for the hot air to get out.
It's a good
Well,
idea.
That is. For those
You
of us
get
who have
these
struggled
at
for
any
45
halfway
minutes
decent-
with, oh, go ahead.
You can get these at any halfway decent stationery store.
Pair of blue jeans works perfect for your hanger.
So that's it, a pair of clean blue jeans and a really good strong clip, huh?
Yeah.
Carburetor's got the same kind of cowling. May I ask one more question for our expert?
Yeah.
Okay, so I love this 87 non-ethanol auto gas thing in my Citabria. It's been wonderful. What is the inside of my carburetor gonna look like after auto gas?
The only thing in a carburetor is the neoprene tip on the needle. That's it. It could swell from the ethanol. And if it swells.
No, this airplane, the only ethanol ever got near this airplane was after flying. That's a pilot joke in the bar. But no, this thing never saw ethanol.
Right. I got you. I'm winking.
It's my airplane.
Yeah, but that's the only thing that's good. If ethanol is going to hurt in a carburetor, if it does.
Yeah, I was just curious because I mean, this is the old style gasoline. We used to get varnish and gum, and remember?
Oh yeah.
I'm just wondering how my carburetor, when I send it to you, what it's going to be like after having used auto gas for the last 15, 20 years.
Well, remember, you're not sending it to me. You're going to send it to Marvel Shebler.
You're right.
All right, so additional questions. I'm going to go back. So back to the hot starting question and vapor lock is essentially, so we've got some great tips from Comanche drivers, is essentially your guidance, Alan, to figure out what works for your engine and then remember it.
Yes.
Okay.
And believe me, if you have enough trouble trying to hot start and then you figure it out, you won't forget.
And you had mentioned on the test flight that different exhaust systems can result in different hot starting behaviors.
I don't know if I said that. No.
You said something. I remember you were saying different engines are going to hot start differently depending on how something.
Oh yeah, it's all about the application, the cowling, how hot it is, all that kind of stuff.
Okay. Question, Jim W., do you want to go ahead and dive in with yours? I think you were next.
Sure. Hey, CJ, it's Roper.
Hey,
So-
Roper.
Yeah. Hey, so I actually put 3 questions in there, but I won't try to take up. One of them was probably pretty quick, and it's a little bit like the hot start, but from a cold start, Alan, first question is, so whenever, from a fuel injected engine, and it says, turn on the fuel pump for, on and then back off, how long, what am I looking for? What I do is I look until I see fuel flow of 4 to 5 gallons an hour, which is normally 2 to 3 seconds once the pump picks up fuel.
That's exactly right.
Is that what I need? So to see about 4 to 5 gallons an hour of flow.
As long as you're seeing fuel flow, you're getting fuel. So yes.
Okay. My next question is, I just about 3 months ago or 4 months ago installed, due to some other maintenance, installed a brand new set of precision fuel injector nozzles.
Okay.
And I noticed that each one is stamped with a cylinder number on it. Yeah. And so as I'm trying to get my EGT spread in cruise a little bit closer, because I use lean a peak.
Yeah.
And it's actually not that bad, but I would like to get it a little bit closer. So my question is it okay to move those around even though they've got a cylinder number stamped on them?
Ours don't have cylinder number stamped on them.
I bought them from y'all, and there's the A, and then they also have a number stamped on the.
Okay, right, on the hex, right?
Yes.
Okay, yeah. Okay, yes, you can take the assembly with the restrictor, keep them together, and you can put it in any cylinder. You can also do a flow test where you take all the nozzles out of the cylinders, you put the restrictors in, you put the fuel lines on, and then you put them all in little measuring cups that you can measure with.
Yep.
And turn full rich, boost pump on, full throttle, full rich, turn the boost pump on for an amount of time to where you can measure it and note what cylinder they're from. And you can take the leanest, put it in the richest cylinder, and you can match them around that. Normally, our nozzles are going to flow 40 to 60 degrees between cylinders.
Sorry, say it again. You said 40 to 60
degrees.
What?
40 to 60 degrees between cylinders with our nozzles.
Okay. Yeah. Okay. Perfect. That's what I'll look for then. And then my last question, CJ, is it okay if I go ahead and ask the last one? I don't want to monopolize
Oh no,
the
yeah,
time.
no, please. This is trust me, if you've got it, about 50 of us have it.
Okay. So Alan, I've been chasing an issue, same thing at cruise. So I cruise wide open throttle, lean a peak, typically around the 10,000 foot range. And what happens to my airplane is after I climb up, I level off and I get set up in cruise, and then my fuel flow will fluctuate plus or minus about a gallon to a gallon and a half sometimes. And I feel like, and without me doing anything, and I know that it's actually doing it because I can feel the engine changing and my EGTs change. But after about 45 minutes or so of cruise, it seems to settle out and it stops. And I've been chasing this and I haven't been able to figure out yet what would make it do that. Any ideas?
Vapor, fuel pump, engine driven pump, starting to act up. Maybe the vent line.
It's got a brand new engine driven pump. And it was doing it prior to.
Everybody always says it. It's a brand new one. Well, people call us when they get brand new engines going, hey, your servo's not working. And I go, well, sure it is. I said, how about your fuel pump? It's not a fuel pump, it's brand new. I go, our servo's brand new. So we have to troubleshoot it to figure it out. But the servo is it's a mechanical continuous flow system, which means other things interact with it, such as fuel pumps, water going through the system. It could be a variety of different little things. Unless the servo is starting to get progressively worse for each flight, it's probably not a servo.
Okay, could could it be and I'm just asking, I have no idea,
Yeah,
and
yeah.
I'm not trying to lead the discussion anywhere. Could it be,
No, that's right.
have anything to do with the fuel divider?
No. The flow divider is either open or closed. That's it. The flow divider is never going to be a flight issue either. It's either works or it doesn't. Once it opens at that 2 PSI, the biggest problems we've ever had with a flow divider is in the cold. We had like a dull reamer one time, and the piston in the flow divider was freezing to the body, and they couldn't start their engine. So they'd have to go put their hand on it for a minute, and then it would start the engine. But it's never going to be a flight issue. It's either going to be on or off.
Okay. My fuel servo is about 10, it's a rebuilt that's about 10 years old. So that was my other thing, was I was just wondering if, maybe the servo's starting to lose its calibration, or there's some internal something that's possibly worn a little bit.
Yeah,
was the other thing I was thinking.
Like I said, if you want, we'll happily flow test it for you.
I'll wait till it's cold weather, then I'll send it to you.
Okay.
What's the turnaround, a question from, while we're on that topic, what's the turnaround time for flow testing? How much time will
we did Kurtz in one day.
Whoa. So if that's the case, then I guess what we need to do is just find out the FedEx or UPS overnight, so our
So
planes aren't down for too long.
I'm the general manager here, so if I go down and ask the production manager to flow the servo when it gets in, she'll flow it for me. And we normally do that anyway, because we don't want RMAs to come in here and sit around. We know that people are down and they want to fly, so we get them done as quick as we can. Like I said, if we get it, we don't usually get UPS till early afternoon. So when we get it, it'll be the next morning that we flow test it, but I'll call you and we could probably ship it out that day.
Have you got some good boxes that we can buy from you to put it in, so when we're sending it to you, it's in the right packaging?
Well, I'll tell you what, if you buy a servo from us, I'll send you a good box with the servo in it.
I can see my carburetor get flowed.
Hey, on the old servo thing, the reason I think mine are also more than 12 years old, the reason I think they're getting close, it runs so nice, but at the beginning of each flight, within the first half hour, in the last 8 or 10 flights, both engines will have a period of time where the fuel flow is just wildly fluctuating on a Shaden that is always within a gallon when I fill the plane. And then they'll settle back down, but nothing else seems to change. The airplane flies beautifully. There's no vibration. The EGTs don't change. But it just seems to have sort of wild fuel flow fluctuations.
Is that till it warms up? Is it okay after it's warm?
Well, it doesn't matter how warm it is, but it never happens after a half hour of flight. Like it's 100 degrees. Like I just flew from Jefferson, Missouri. It's hot when I'm taking off. It's really hot.
Well, I don't know how you Comanche guys, I mean, most of your servos are horizontally mounted, right? They're not vertical.
Right, they're in the back of the engine.
Yeah.
So Mike Ellis just threw an idea in, since John, you and Roper both sound like you're getting fuel fluctuations. Mike just suggested, could it possibly be that the fuel tank vent isn't routed correctly?
Well, I mean,
It's kind of a crazy idea, but he mentioned 45 minutes, then it goes away. He's high altitude, full power. Those caps on our fuel tanks are like thermos caps. They're not supposed to pull air in. That makes me think maybe that tank is partially collapsing until it dumps some gas out of it. I don't know. It's a wild idea. I just didn't know if maybe you had explored that.
I haven't. The two auxiliaries are brand new bladders this last annual, and I've flown it this year about 170 hours.
Wow.
So I fly for business. So is that like, what is the symptom of when these things are getting just old, Alan? Like what will we see in the cockpit?
Well, I'm not sure. I I'm envisioning your application and where it is.
Yeah.
And I'm not sure if fuel can get down there after shutdown. Because what happens is it gets down into the servo on the air side, the Venturi suction, sucks it up to the dry side of the servo where it's supposed to be dry. And what happens is it starts getting gummed up in there. And then when you start your engine and you warm it up, it loosens up and it goes fine. And then the next day you come out and you go, it doesn't run good. But a few minutes later, it's running okay. And then, you know, we get it and we find a bunch of junk in it. So I'm not positive, but
if they just get old, if they're just getting old and stiff, what are we as pilots going to see? Like, what are some symptoms, some tattletales, the canary in the coal mine, whatever the phrase is?
Well, the springs in the servo, you know, we use the springs on the diaphragms. Those could get weak over time. But I think you're going to see a progression of it getting worse. It's not just going to be there one day and that's it. It's going to get progressively worse on each flight. It's not going to, I mean, these things easily will go to TBO as long as there's no contamination in them. So it's when you start putting, you know, oil coming down from your intake or your exhaust valve leaking down through there, going down the intake tubes, going into the servo, over priming, you know, running down, getting into the servo. I mean, you know, landing on really dusty runways or dirt runways or whatever. Just anything to get that stuff sucked up to the air side of the diaphragm. But other than that, I really can't tell you. Now, here's another key. You should be able to turn on the boost pump and off and have no operational change. If you turn the boost pump on and you get a change in operation, it could be the servo has a problem.
I'll try that. Thank you.
Yeah. Yeah.
Hey, Alan, sorry, CJ, to jump in just for your SA. So like I said, I think for our 6-cylinder Comanches, the servo is vertical mounted on the bottom. It's just the 4 cylinders that it's mounted on the back, I believe.
Oh, okay. Yeah. So if it's mounted vertically, you could have all those problems that I mentioned over time.
That actually sounds like mine because it only happens on the first flight of the day as well.
Yeah.
So,
I'll bet you got a dirty air diaphragm.
Copy. And send that, basically it's time for a rebuild.
Well, how old is it?
It's 10 years.
I mean, if it's going to get rebuilt, you should just buy an exchange unit and have the 2-year warranty. Our warranty is 2 years or 1,000 hours. So we take care of any repairs that if you have any problems with it, we pay for the repairs. So it's not prorated or anything. You just get 2 years or 1,000 hours. And if it's getting old, just buy a replacement. They're $1,500 for a replacement. And an overhaul is going to cost you almost the same if you send it somewhere and you're not going to get a warranty. Or you're not going to get a 2-year warranty anyway, like ours.
Well, that's a good tip.
Yeah.
So we can buy that directly from you guys instead of Aviol or Aircraft Spruce or whatnot?
Well, no, we have distribution. We overhaul them for distribution. We sell a lot through Aircraft Spruce and we sell a lot through Quality Aircraft. The thing about Quality Aircraft is they actually work on these units, so they have more knowledge than Aircraft Spruce does, but you're more than welcome to buy from Aircraft Spruce because it's our warranty. So if you buy any fuel control from anybody, we want you to call us direct. We don't want you to call the distributor back and go, hey, call us because we can help you with it and get it taken care of quick. Like I said, if you get it to us, it's a day turnaround. I can do a day turnaround.
Well, are you going to turn back the old unit that you cannot sell them a new one, or are you going to say, hey, here's a shot, here's a rebuild one, and send back the rebuild?
Yeah, well, if it's close to TBO and it's over 12 years old, you know, we don't want to work on them if they're over 12 years old because we agree with what Lycoming says. It's TBO of the engine or 12 years calendar time. So we don't want to repair something that's 12 years old and older. I mean, we have other shops in the US that will do it, that I could refer you to, but if you're close to TBO and it's probably best just to buy the exchange and be done with it. That's just my view. I mean, you guys are rich, right? You guys can afford all that stuff.
We had this
Remember,
discussion.
that's why I
about the fact
can't, that's why I don't have an airplane. I can't afford to fly.
I'll tell you what, the Comanche group is interesting because we have people maintaining and buying these airplanes on, 50-year-old military pensions, and every penny goes to fuel that isn't spent on food and taxes. And then we have people who could fly anything they wanted and they just choose to fly a Comanche. So, but we have more of the former than the latter.
Remember, if you have to complain about the price of fuel, you can't afford to fly.
The reason I asked whether we could buy directly from you is that I was tantalized by the $1,500 price. So I just double checked. It's at Aircraft Spruce, it's $1,850. It's not $1,500 per servo.
Don't you have an RSA 5 AD1?
I have an RSA 5. They list a part number of 2524145. And the cheapest one on their website is $1,800.
What about quality? What's theirs?
Oh, I don't know. I don't have an account there.
QAA.com. Well, yeah. I mean, you can just search it right on the homepage.
Sorry, I love a good price.
I just said 1505 is what I've seen RSA 5s going for from quality.
Yep. All right.
Yeah. And you know what, Alan, we've been arranging group buy specials on various parts of interest to Comanches. So
yeah,
if it's an option, we can organize, 5 or 10 that want to purchase the same part. And you can say, hey, bring us 5 or 10 and we'll give you a discount.
I'll give you a discount.
I'm going to call you and get an RSA for this carburetor. I'm liking this guy more and more every time he says stuff.
Wait a minute. You just said an oxymoron. You said, I'm going to get a servo for this carburetor.
No. An RSA. What do you call it? An RMA? A number.
Oh, RMA. Yeah. To send yours in. I mean,
right.
That's if you want it flow tested.
Right. So call you up, get the RMA number and send it in.
Yep.
And if it turns out to be a piece of junk, we'll talk about getting the fresh one sent back instead.
That sounds good to me.
Excellent.
I'll give you a discount off.
Good deal. We got one question that Joe W has been very patiently waiting to ask. And that is, what about Joe W, do you want to just unmute and go ahead and jump in, or do you want me to ask it for you?
I think he already answered it with the heating and the boiling of the I think the gas is boiling through the system and out the overflow. That's what I'm having dripping of fuel underneath the cowling for about 5 minutes. So not all the time, but on hot days in particular.
Yes. What happens is when you shut an engine down, you still have the system still pressurized. So when it's relieving its pressure, if the piston in the flow divider, it's flowed to 4/10,000ths of an inch clearance, but it's still enough for fuel to seep up, go down the fuel line, go into the air, above the intake and go down the tube and leak out of the bottom. Also, remember those valves I told you that can leak up to 5 cc's a minute? Those are also leaking. So you may see a tablespoon of fuel underneath the cowl in the morning, or a little teeny puddle. That's from the residual fuel pressure bleeding off the system.
Thank you.
Yes, sir.
Cool. A couple of people actually had that question, just so you all know. There's people sometimes direct message me and ask, hey, can I get this in? So Joe,
Where'd she go?
Yeah, her internet just faded out is all I think.
Oh,
QAA absolutely is $1,500, so that's awesome.
But yeah,
1,500?
Yep.
See, I didn't lie to you.
No, I just thought you might be optimistic. Like I want the good price.
See, that's why you shop around.
so what John
$1,800
is
at
crowing about,
Earth
everybody,
and
is he
There's
just checked QAA, and in fact, it is cheaper by $300 than spruce.
Times 2. Because 2.
Oh, right, twin engines, yeah.
Well, there you go. Just send me cash. But I welcome everybody to stop by at Oshkosh. I'd like to meet you because it's kind of fun talking to you guys about airplane stuff. I love airplanes. I flew airplanes, radio control ones for 35 years, but I could have any airplane I wanted.
And you know, Alan, if you want to come over to ComancheTown, we're expecting probably at a time 40 birds, maybe 50 coming through ComancheTown. And we usually grab a couple of mornings to just do sessions. So come over and talk to us too if they ever let you out of the hangar C.
I'm telling you, man, just thinking about what's going on with Oshkosh, I think it's going to be busy.
Oh yeah.
Yeah, I think people are going to come and make up for the lost time.
Holy cow. And folks, it is amazing. We've been at this for almost 3 hours. It's 5 minutes to 10. We're just going to open the floor in case anybody has other questions or things you want to say about anything. I just want to thank Robert Klein and Pete Morse for doing the recording and backup recording that's going to make this recording available to everybody else, including some of the cool troubleshooting that just happened. And I'm going to just shut up and anybody jump in.
Hey, by the way, you can delete that now. Okay, I'm done.
But and I just also want to say that Alan, this is an amazing discussion, really fun, really informative, and nobody could have done it but you. So thank you for making this available.
Yeah, I feel special again. Thank you very much. You know, like I said, thanks for having me. It's so nice to be had.
I'm not gonna touch that one with a stick.
I'm gonna touch him. I wish I could pat him on the back. He's my new best buddy.
Well, I love you too, man.
Very cool. And by the way, as far as we know, everybody, Tuesday night gumbo at Oshkosh is still gonna happen. And so come in, register for Oshkosh at northeastcomanche.org under the one of two ways. You can go into the fly-ins and ComancheTown's there, but you can also just go into northeastcomanche.org and go to any form links. And in the bottom right is the how to register your tail number for Oshkosh. And then in the top left, if you want to list buy, sell, trade parts, something you're looking for, something sitting in your hangar that other people could use, fill in that form. And if you have suggestions, criticisms, comments, whatever, there's a form there for that as well. So have at it. Well, Alan, I think we talked him out of talk.
Nice. It's only 7 o'clock for me. I can go home and mow the grass.
Admit it, you're starving.
Yeah. I'm having a pot pie for dinner.
That's funny. I just made one of those too, shepherd's pie.
Oh, I love shepherd's pie.
Oh, good stuff.
Yeah.
It's a Vermont. So that's Vermont special. Well, we got 30 people still hanging in there with us after all this. And we've had a bunch of people knock. I just wanted to say, if you hop into the chat window, Alan, you'll see a whole bunch of thank you notes and appreciations. So it might be worth it. I'm going to leave this meeting up for a few minutes in case folks want to just chat with each other. Mike Ellis just said to share Serge for hot starting lock. Try this, and I'm just going to read it out because this affects so many. Try mixture idle cutoff, throttle full red, boost pump, you hear the pump fill, and then hit your starter. And when it starts to fire, mixture in and throttle to idle.
And if it works, that's what you use for every time.
Yep.
Okay,
It'll work.
I'm gonna throw my black hat at it again because I'm doing the recording. And I'm gonna end that right now. It will be available tomorrow on the website. It said the whole thing, and you can jump around in it, see whatever you want to see. So as far as I'm concerned, I'm gonna say goodnight, at least with the recording, and then I'll hand it over to CJ. So that's the end.